work. So yeah, welcome to the second Northern Soil CRC Communities of Practice workshop. I'll share my screen now so we can just have a bit of I just made a bit of a short PowerPoint just as by way of introduction. I might just, I shouldn't turn that off, that's okay. So we'll just run through it just really short. So yeah, just welcome to everybody. What we're going to run through today is a bit of peer-to-peer learning. So I've asked you all to think about something that you would like to present to the group. But just sort of 10 to 15 minutes on, I'm just thinking between, you know, when we caught up in December and what's been happening now. There might be some learnings that you've got, some research trials or demonstrations that you'd like to share, or some experience that you've come across in a farmer's paddock that you'd like to share that would be relevant to the Soil CRC Communities of Practice. And then if we've got time, we'll have a bit of a chat about the paired activity, and I appreciate most of you giving me some feedback about that. So we can have a quick look at that. Some of you have identified partners that you'd like to work with, which is great. And so we can go over that and then perhaps have a bit of a chat about some future meetings and how we might progress in this environment that we're working in at the moment. Which is a bit isolated, but I think we can capitalise on it and perhaps, yeah, have a look at these, propose some perhaps catch-ups a bit more regularly. And I've been talking to the program leaders and getting some information about appropriate speakers and expertise that we'll perhaps be able to bring in and just do, you know, an hourly webinar with 2 or 3 speakers at a time that gives you the opportunity to dig a little deeper into their knowledge banks and ask the questions that are relevant to your region. So that's what we'll get through today, hopefully, and I'll make sure that we'll have some breaks. So we'll start off and perhaps we'll have a break at about 10:30. And then another one at say 11:30, and we'll just sort of keep them short. But I'm conscious that this sort of environment is hard work in regards to sitting at a computer and concentrating and taking it all in. So yeah, I'm happy to take breaks and for you to stand up and walk around if you need to at any time. So, which we would do if we were in a workshop face to face anyway. So that's all good. And if there's anything that you think of during the time that we're together, write it down. I hope you've all got your Soil CRC pens. Take some notes and make sure you raise it at some stage during that time that we're together today. So yeah, welcome that interaction. Just a bit of a reminder about where we all are. I'm not there, but I'm right down the bottom, sitting in the middle of the centre of Victoria. But this is, I guess, also for Anne's benefit. She can see where everybody is, but it's also in the Communities of Practice capacity building plan. So if you ever need a reminder about where we're all located. And just a bit of an update on what our objectives are. These are some of the priorities that we identified at our first meeting. So talking about identifying soil health, managing soil carbon, understanding soil biology, motivating landholder practice change, which is really what we're all about, trying to assist landholders to make the best decisions about managing their soils environmentally and productively. And we'll be identifying that expertise within the Soil CRC network and then coming up with a plan going forward after sort of the next 12 months of meeting and learning and catching up. This is a nasty table, but it's just, I just thought I'd mention it, that I've put together a list of the Soil CRC projects, which I think are relevant to the communities of practice that we're working with, and you can see which groups are involved in those projects. So information about all these projects is on the Soil CRC website, so you can go and have a look at those. But I just thought I'd pop that up so that you can see, and I've also put it in the latest edition of the capacity building plan. So you can have a look at that as well. So I think that's all I really wanted to identify for the start. This is really, and I've got some information there about the paired activity, but we'll perhaps deal with that a bit later on. So this is really your time to share some information, and I'll try and work out how I can, oh, there we go. Stop sharing my screen so you can't see all the hoo-ha that I've got going on in the background. So yeah, I'll just pretty much work through each of you, and perhaps, and I can see you up big and strong on my screen at the moment. So perhaps we'll start with you if you're happy to start off to share some information with the group.
Wonderful, thank you, Felicity. My presentation is basically it's a draft of a document or a presentation that I'll be doing next week as part of the Bachelor of Science that I'm doing, which is very relevant to our agricultural industry and particularly soils. And what I wanted to do was run through this and get some feedback, see if in fact that you had even heard of some of the things that I'll be talking about, because it is actually new research. And it does have some interest, particularly for the future, for good, healthy food, and how we actually manage, excuse me, our crops and soils in the future for with healthy production. So I'll just share the screen now, and we'll get going and see how we go here, Felicity, with this one. Okay, can you see that?
Yeah, perfect.
Okay, so the intention is, after this has been presented next week as part of our assessment, that if you're interested as a group and you would like to get a copy of it, we'll get permission so that you can actually share it and use it if it's of interest to you. A couple of other, David and Renee, have worked on this with me as a team. This is just an abridged version because next week is going to be a Q&A style of presentation.
Great.
So just to give a bit of background and context to this, and reference to science, that science is a way of knowing, and it's an approach to understanding the world. And without science as a background, we wouldn't have collective knowledge to be able to progress with research and science. And particular to this science is the impacts that it has on soil health in Australia. So more than 60% of the land use in Australia is agricultural, and nearly 50% of agriculture is plant-based. Industrial agriculture has created many common problems associated with monoculture crop production, including soil compaction, loss of soil structure, nutrient deficiency or degradation, soil salinity, and land managers are now starting to look for other practices that will help to regenerate or maintain their capacity to continue to produce healthy food and crops. Okay, so to protect our valuable soil, we need to understand how to meet the needs of plants. How do plants get nutrients they need to survive? How do they eat? So just a little bit of background here based on the accumulation of knowledge. In 2010, a research paper demonstrated that plants or microbes were functioning in around the root hairs and observed the degradation after a few days. At that point, they recognised the rhizophagy cycle. In 2018, Professor White from New Jersey in the US actually looked at the study and accumulated information a lot closer. He was able to actually put dye through the system to actually understand how plants actually are fed by microbes. So the research paper that we've looked at is the rhizophagy cycle, an oxidative process in plants for nutrition extraction from symbiotic microbes. And just to give you a bit of background on that, and as to how new this research is, globally, it includes 4 institutions across the US, India and China. So the science itself, or the research, is only just at the start of its research, which is pretty exciting. There's a model that is extracted then from the documents that Professor White, or the research paper that he's actually produced. And we actually have been able to exchange emails with him to get permission. And he would also like a copy of this presentation when we've completed it as well. So this is the particular part of the process which is of importance, is to how the microbes feed the plant, and then how the plant actually, or through the root system and the root hairs, actually spits out the microbes, and they go off to collect and hunt for more food. So what that has in terms of relevance to society and why this is important, I think we've all got to the point where we appreciate that for healthy soils, we need to have healthy microbe communities. And then the potential to manage crops with microbes. There's been already quite a lot of work done in biology, and also the industry, in terms of using microbes in different ways to get different outcomes, particularly with regard to plant health. Production of seed vectored microbes is another potential in the future. So current knowledge is available in science to manage for healthy soils and microbes, but that's expanding. Obviously, we want to try and reduce the need or the impact of inorganic fertilizers and pesticides in our environment, and research into bioherbicides is part of the process, which Professor White is now continuing his studies on. We're all very conscious, obviously, of the need to reduce soil and water contamination, and the projected future for world or the global population growth, and to be able to support that growth with good quality foods is going to be critical, and also having healthy people and environment. So there's some very positive outcomes coming out from global research. So the technologies that have been used, I'm just going to catch up here so that I can, if you just bear with me for a second. So in the studies that have been conducted by White and his colleagues, comparisons were made between sterile grass and dicot seeds and seeds inoculated with Bacillus, Plasmodium and Micrococcus bacteria. These microbe experiments used a staining technique with a chemical DAB to highlight the release of superoxide used to degrade intercellular bacteria. This is demonstrated here by the brown pigmentation. The introduced bacteria are counterstained with aniline blue to show where bacteria are present. To describe the rhizophagy cycle in healthy soil ecosystems, form the rhizosphere where the roots exude sugars and minerals that attract a diverse community of microbes. We know these microbes carry with them nutrients essential to plant growth. This is the first phase of the rhizophagy cycle, the free living soil phase. Picture 1 shows the next stage of the rhizophagy cycle with microbes entering the root meristem. This is kind of endocritus, while the biofilm around the bacteria that helps move them across the membrane, living in space between the cell wall and the plasma membrane. Picture 2, reactive oxygen, released from the plant cell, strips the outer wall of the microbe where they become wall-less photoplasts, creating nutrients for the plant to absorb. Picture 3 shows further exposure to a superoxide which extracts more nutrients due to leakage from the cytoplasm. As you can see, they become more transparent than in number 2. The lack of rigid cell wall increases the size and shape of these L-form bacteria. Some microbes don't survive the highly oxidative environment, but others survive and begin the next phase. This is where the researchers are able to show the cyclic process of rhizophagy. The bacteria trigger the fine root hair formation. Bacteria begin to move along the structure until they collect at the ends and are expelled back into the soil matrix. The evidence shows that once the bacteria are expelled to the root hair, stop growing, suggesting that this is a function of the intracellular bacteria that helps plants from basic function and structure. The bacteria go on to reform cell walls, collect nutrients, and start the cycle all over again. In terms of how we find out about this information, we've already seen globally a number of soil scientists this year that have commenced extension. And I think if we're in the soil space, I'm sure that you all would be familiar with these particular people. Dr. Christine Jones recently spoke at a field day at Ebor on the rhizophagy cycle. Nicole Masters certainly has in a lot of her podcasts and webinars, and is very focused on more information about how she can utilise and understand that part of the process. And if you're interested, John Kemp has also done a really beautiful Q&A with Professor White just recently, which is also worth a listen. So that's how extension happens. And with these three people, we're already getting extension locally, nationally and globally, which is really important for technology that's going to impact us and soil health. So what we wanted to have a look at here is some of the beneficial outcomes and the application of this from a research perspective. Common practice in agriculture is to chemically treat seeds to remove particularly in cotton, to delint the seeds. And in that process, we remove all the natural microbes that actually collect in the seed. So that seed then, as a bare seed, is graded, and then it's treated again then with fungicides and pesticides to help that plant survive in the soil, in its environment that we're exposing it to. So we're actually removing a lot of the natural microbes that that plant needs and uses to survive. So we're artificially supplying those through to them. This research then opens up the opportunity to be able to utilise an understanding of it and perhaps use microbes in a different way when we're actually treating the seed to give it the best possible start that it can. An interesting outcome of the research was how some bacteria promoted growth in one species but impaired growth in another. Professor James White is now conducting research into the use of this knowledge to potentially develop bioherbicides using the endophytic bacteria. So from this research, we're actually finding a lot of other secondary pieces of research that the researchers are now focused on, which will also have an important part to play, I believe, in the future of agriculture. So in summary, the importance of the rhizophagy cycle, obviously it's increasing our understanding of the symbiotic relationships of microbes in our soils and how they react and how they feed plants. And I think too, one of the key things, I think we'd all be aware that we have had observations of biostimulants and humic substances in the past, without any real knowledge of knowing how they actually work or provide benefits. So I think this is the start of how we can actually understand that process better so that we can actually support and boost the growth to support it with supplying nutrients to the plants. There's a new focus on managing soil ecology from a crop production perspective, and ultimately what we want to do is reduce over time the use of crop inputs, particularly those that have negative impacts in our environment. But overall, the key is to provide a positive environment all round for everyone, good quality food, and obviously the outcomes that come from quality food. And this is from a global perspective, so I think you'll start to hear a lot more about these processes and that impact. So I hope that that's been of interest to you, and happy to answer any questions if I have the knowledge to be able to answer them, or I can certainly find out.
Terrific. Thanks, Anne. That was That was way over my head, but a good reminder to back into the actual science behind what we're trying to do out in the paddock, you know, and the processes and understanding, what's happening right at that detailed level down in the soil at the roost sheets and that sort of thing. So fantastic, really great detail there and explanation of what's going on. So I'm happy to open it up if anyone's got any questions or comments, if anyone would like to say anything to Anne about that or their experience.
Yeah, I would. It's Cole. Anne, I loved it. Great preso, great topic. What's your feeling about the future? Will we be buying our bugs in bottles and bags and putting them on, or will we be looking to grow our own in the soil through getting the soil ecology happening?
It's a really good question, Colin. I think there'll be a combination of both. Obviously, if we can actually nurture the natural microbes that are going to give us the best output, we need diversity. And I think that's one part of the process. But to get there in this transformation process, we may need to add, and we will need to add, additional microbes to the system to actually get us to the point where we have an ecological system under the soil that is going to provide us with the nutrients that perhaps we can look back and say, okay, well, we can now wean ourselves off perhaps some of the very high rates of synthetic products that we're currently using. Because I firmly believe that from the space that I've been working in with regenerative agriculture, that they are starting to show the benefits of a more natural way of doing agronomy, or agroecology as it's now been called. To give you an example, Cole, of I knew very little about biodynamics, so I did a biodynamics webinar just recently. And one of the things with biodynamics is that they use horns from cattle in their processing. We are now breeding cattle without horns, so they're all polled cattle. So there's becoming a scarcity of horns for that type of processing. So they're already starting to think about how that they can actually manufacture and support that part of the process, given that they in the future may not have horns as part of their processing. So very interesting space to be in at the moment, Cole.
Yep, certainly is. Good on you.
Felicity, could I just have a quick plug here for the Soil CRC around some of the work that Anne has also presented. So great presentation, Anne, thank you. I'd just like to also point out that the CRC has got a couple of projects that are highly relevant to Anne's presentation. So for example, Anders Claessens is a PhD student, and he's been working now for the last 2.5 years on endophytes in the sugarcane system. I think Richard Hobbs has had some chats with Anders in the past, and we've been having a look at the role of cover cropping and the succession of endophytes and arbuscular mycorrhizae and their role in sugarcane production. So there's some really high-end science there, in particular having a look at gate effects. So why does a plant root system accept one endophyte or one species of VAM? Because there's not just one species of endophyte or one VAM, there are at least 6 or 7 classes. And what we're finding is that, or what Anders is finding, is that the species that the plant has actually accepted into its root system and is working with through a handshake agreement is not necessarily the dominant species in soil. So there's a gate effect, there's some sort of communication between the plant and the root system. And that particular aspect is also being worked on by another PhD student, Cameron Copeland. He's based at DPI Wollongbar and also through Southern Cross University with Terry Rose and some of the team down there. And he's actually having a look at some of the chemical profiles using an approach known as metabolomics, where they're having a look at the chemicals that are being released by both the microbes and the root system. So the plants will generate new carbon through photosynthesis, and they can then adjust their profile of organic acids, amino acids, sugars, complex carbohydrates that it releases into the soil system, which can then act as a gate effect and control the actual rhizosphere. So there's a lot of work going in that area. And I just also like to point out that Leslie Weston at Charles Sturt Uni in Wagga has got a pretty major program on bioherbicides as well. So yeah, a lot of the work that Anne presented is from overseas studies, but I just also like to point out that there's a very strong research effort in Australia as well. So maybe we don't, or the Australian researchers don't promote their information well enough, but there is a lot of really, really good local research and information coming through. Thanks, Anne.
Thank you, Lucas. And I would, highlight what Lucas just said. The extension of information is really key to whether or not we're actually understanding what is actually going on locally. So that's part of, this, what we're trying to achieve with these presentations is to actually try and work out where there's gaps, I suppose, in extension to industry from the scientific community. And, it's obvious when you go through this that a lot of work is done overseas, but in fact, one of the studies that I did put up in 2010 was there were Australian researchers involved with that actually discovered the rhizophagy cycle itself. So that's pretty significant.
Yep. And Felicity, maybe Anders could give a webinar at some stage. She gives a really interesting talk, has got some wonderful photography of roots and also some great DNA evidence. So I think that might be, if people are interested in the rhizosphere and soil biology, he would give a great presentation in that area.
Yeah, that would be fantastic. Yeah, I think, yeah. So yeah, happy to provide, the group can provide me with some feedback around that, and certainly something we can organise for sure. Thanks, Lucas. I appreciate your comments. Has anybody else got anything they'd like to add?
Yeah, I just had a question, Anne, probably more in relation to what, I guess, testing facilities or businesses are out there to do this testing. At the moment, we've been using Predictor-B with Sardi. Is there options out there to get some, cost-effective testing done?
What I can do, I'm not familiar with any, but what I can do is contact Professor White and find out and see what suggestions that he would have, because he's very much where he works. He's applying that. They have a fantastic orchard and cropping program where he works from, and they do apply a lot of the technology in the field. So I certainly will follow that up for you, and I will get back to the group and let you know.
Yep.
Lucas, do you have any comments around that testing?
Yeah, as Brendan pointed out, Predictor-B also have got a new test now for VAM, a DNA-based test for arbuscular mycorrhizae, and I think they can separate that into the 5 classes and 8 subclasses of arbuscular mycorrhizae that are present. I don't know if they do endophytes. I think endophytes are still in the realm of either a gene sequencing approach or a microscopy approach. I don't know if they're done commercially, but they're certainly done in research labs.
Thanks.
But I'd be happy to follow it up with you, Brendan.
Yeah, that's one of the things that James has, Professor White has highlighted, that pretty much most of his work's been done with dye and a microscope to date. So, but certainly I'll follow that up with him.
Thanks, Anne.
Yeah, and I'd certainly echo what Lucas has said. In the small amount of work that we've been doing with Predictor-B, we don't even know what species are out there or what crops actually each individual species. So at the moment, it's just really dipping your toe in the water and seeing what's out there.
So it's really a yes or no.
And also, I guess, a Longfellow disorder impact with low AMF levels.
Yeah, Anders has been working on some of the Longfellow disorder issues in sugarcane, and there's some pretty interesting data there actually. So I think he would definitely be worthwhile presenting here.
Yeah.
Terrific. Thank you. Anybody else like to? No? Okay, no worries. Fantastic. Thank you, Anne. That's a great start. So we might move on. Brendan, are you happy to go next, or would you like to nominate somebody else? But yeah, I just can see you on the screen, so happy to invite you to share some information.
Yeah, that's fine. Yep.
Thanks.
Right, I just need to get it up here. How do I get this up? Bear with me.
That's okay.
Can you see that? No?
So you need to go down the bottom. There's a share screen little, you
Hang
just
on.
copy it. Yep.
Coming.
Yep.
Can you see that?
Yeah.
All
Great.
right.
Thanks.
Good.
Yeah.
Righto. So yeah, this was one of the projects that we've been currently working on. The issue initially was brought up some 4 years ago, I believe, from our Walgett group of consultants. So they identified it as a priority out in that neck of the woods where, for those people, Walgett, I'm talking probably 150 odd Ks west of Narrabri, pretty much northwest New South Wales, so in some extremely marginal farming country. So they identified an issue there where they had what they referred to as high magnesic soils. So not an issue so much as high magnesium, certainly high magnesium, but it's a ratio of the calcium to magnesium ratio, So just having so much magnesium in the soil, which pretty much overrides the calcium. We set up a site back at Burren Junction where they have this issue where a lot of growers out there seem to, rightly or wrongly, go and apply a lot of gypsum with no real economical basis to it. So we were asked to set up a trial and see if there was anything actually in it. We set the site up in 2016 and unfortunately they haven't received a drop of rain since, and consequently we could never grow a crop in the paddock to identify whether it was going to work or not. So what we've decided is to set up a new site up here on the Darling Downs, a little bit closer to home for us, so that we could manage it a little bit easier. And we set it up as a small plot trial so that we can include a lot more treatments as well. And that's what I'm going to talk about today. So similar, the aim of this, I guess, project or trial was to investigate the impacts of soil ameliorants on what we call high magnesic soils. And also we found that it was extremely low in phosphorus as well. So to look at the economics of placing phosphorus deep in the profile. So a bit of quick background. You can see by the photo, it's one of those lovely soils that we all love to deal with. As I say, high magnesic soil, a very low calcium to magnesium ratio, less than 1. So we know that ideally the calcium to magnesium ratio should be at least 2 to 1 and preferably up to 6 to 1. As you can see there in that 0 to 10 centimetre depth, looking at the exchangeable calcium versus the exchangeable magnesium, it's certainly well less than 1. Coal P levels in this environment are, down to 23 milligrams per kilogram. So probably reasonable for our neck of the woods. And then down to that 10 to 30 centimetre depth, you can see that calcium to magnesium ratio is still less than 1, so fairly consistent through the profile. And our Coal P, their levels drop down to 8, with the BSES or acid P, as some guys might refer to it as, less than 10. So certainly a site where we would expect to get a fairly likely response to placing phosphorus at depth. The issue for the grower, no surprise, overall poor crop performance, and the characteristics of these high magnesic soils being very similar to what we'd refer to as the normal sodic situation, being that extremely hard setting soil, surface crusting, causing poor water infiltration, certainly poor crop emergence, and just really difficult to manage. It's one of those soils where, it's too wet to plant today and it's too dry tomorrow type thing. So a very difficult soil to manage. So we're asked by the consultant and grower. So the grower in this particular paddock was happy to go ahead and commercially start looking at gypsum application, but approached us, and because we could do it small plot, we could include a lot more treatments, obviously, and follow it through for a number of seasons as well. So our trial design was obviously small plot, and by small plot I mean 2.5 metre wide by 12 metre long plots, and it was set up as a randomised complete block design. We had 16 treatments by 4 reps, and I will go through the treatments later on, but just very briefly, I guess the treatments consisted obviously of an untreated control, where we also had a combination of surface applied gypsum, some deep application of gypsum, compost, and also phosphorus as well. So we applied or set up the trial on Friday the 15th of November 2019. We effectively, applied all the treatments. In terms of the deep ripping, we placed those products down to a depth of around 25 to 30 centimetres on a 50 centimetre row spacing, or tine row spacing, should I say, tine spacing. So the plan is to, obviously, we've applied the treatments, and ultimately is to follow this small plot trial through for the next 3 crops, or I'm assuming probably at least 5 years. And by looking at EM38 data, NDVI, taking it through to yield, so going out there with a small plot harvester and looking at the grain quality. So the intended next crop, or should I say the first crop in this trial, is going to be hopefully a sorghum crop in this coming summer. They had hoped it was going to be winter this season, but we just simply haven't had enough rainfall as yet. So the first, I guess, assessment, which I actually did on Monday, thinking that this might be something good to bring up here in this meeting, was to go out and just do a first initial assessment of an EM38 over that trial site we set up. So as I say, I did that on Monday, which effectively is 172 days after application of when we applied those treatments. In that time, finally, this area has received about 300 mil of rainfall, and that was all received between January and March this year. And we've had very little since, as you can see by the photo. There's not a chance of planting that to win a crop. So for those that don't know, I'm not sure if everyone's up to speed with EM38 and what it does and doesn't do. We use an EM38, and effectively it can measure, I guess, the conductivity down to 3 different depths, being 0 to 150, 0 to 75, and then 0 to 37.5 centimetres. So we assume, and it's an assumption, that if all things being equal in the soil, that the only real difference theoretically will be the soil moisture content, and hence being conductivity emitter and reader, that any differences that we see should theoretically relate to differences in soil water. So what I do is we go out there with an EM38. The plots are all obviously marked out by either wheel tracks or pegs in the ground, and I take 4 readings per plot, and then we average those. So this is the treatments, or the 16 treatments that we did set up. I'm assuming that you guys may be interested in some of the treatments that we did set up. You can see I haven't included all the data because it becomes a little bit mind-numbing when we start talking stats, and I don't want to bore everyone with statistics. But that is the treatments. You guys can probably read them as well as I can talk about them. As you can see, we've got obviously the untreated, some different rates of surface gypsum and also compost, and then looking at that deep ripping effect only, and then where we've obviously applied deep P, gypsum and compost as well at different rates and in different combinations. So from the results you can see there, looking at the EM38 data, what we could find, no surprise, is the impact of the deep ripping alone. So looking at the untreated, we can see that it is significantly higher EM38 reading in the untreated compared to where we've effectively gone through and deep ripped. So that, I suppose, is an answer in itself, in that the impact of deep ripping has certainly dried out that soil profile, and that's after 300 mil of rainfall has been received. I'm happy to talk about all the other results if you like, but I don't want to bore everyone, and if someone is interested, I can shoot it through to them. But I guess that was just a very quick, in a nutshell type result we can discuss. I know in the previous meeting, Tim was talking about strategic cultivation in that neck of the woods. And I know a lot of the groups up here in our neck of the woods have been contemplating it and talking about it coming out of the drought, and whether or not by roughening up the surface or creating furrows that we can try and capture more water and hence improve our fallow efficiency. So this is one trial that we have been looking at. We have set up probably another 3 or 4 similar trials. And in every one of those trials to date, we have shown significant, I guess, reductions in EM38 readings where deep ripping has occurred compared to where the paddocks have basically been left untouched. So whether that is of interest to you guys or not, as I say, certainly take on board the environment which we work in. Extremely low rainfall, and certainly has been very low rainfall over the past probably 18 months, 2 years. So very little stubble cover or ground cover. And that is really the impact of what we've seen so far to date with deep ripping. So as I say, the EM38 interim results to date is significantly lower EM38 reading at all 3 depths where that deep ripping has occurred compared to the untreated. And to date, there's been no clear result from any of those gypsum applications. If you want, I can talk about it. I guess the concern we have to date with applying gypsum, whether it's surface applied or deep applied, is that if we do get a higher reading, using an EM38, we can't distinguish whether or not it's caused by, I guess, the added salts in the gypsum and hence giving us a higher conductivity reading in the EM38, or whether or not the gypsum's actually working and it's actually giving us more soil water. And the only way for us to determine that is to go out and do some gravimetric soil water contents, which then makes it extremely hard in a small plot situation. So I guess the jury's still out on whether or not those gypsum applications are working. And ultimately time will tell once we get some crops in the ground and we can start pulling some yield data back off those plots and crunching the numbers that way. So that's about it from me. Any questions?
Thanks, Brendan. How deep did you rip?
Down to 25, 30 centimetres.
And is that where the deep pea was placed as well?
Yes, absolutely. Yep.
And the gypsum and the compost?
Yes, it was all placed at that 25 to 30 centimetres, yes. And we simply could not go any deeper. We had, a 200 horsepower tractor and it was sitting spinning. So that was it.
Brendan, do you have any data on the exchangeable calcium after the gypsum application, or actually 300 mils of rain should have been enough to dissolve the gypsum? So I would imagine that your calcium to magnesium ratio should be looking a little bit better, especially with 10 tonnes of gypsum.
Yeah, good call, Lucas. No, we haven't, but that's something that we certainly plan to do. At the moment, it's still an issue of the soil is just so hard and dry. Unless you go out there with a hydraulic probe, it's like trying to dig concrete at the moment.
Yep. Yeah, the proof's going to be in the pudding, I guess, when you get the crop on there, isn't it? So, yeah.
And that's always an issue and a question for us is how, like you've just mentioned, to go and grab some soil samples. Certainly easy where we've surface applied, where it's been broadcast spread evenly. But we then start talking about banding it in defined little strips. It becomes a real issue of how on earth do you sample that? So we've always just relied on basically planting a crop and letting the crop tell the story.
Felicity, could I also just give another quick plug for the soil CRC? So Jason Condon at Charles Sturt University has got a project where he's looking at the mechanisms for amelioration of constrained soils. And he's got, I think, 2 or 3 examples of alkaline magnesic soils in those trials. So he's setting up basically lysimeter type studies where they're investigating a lot of the soil chemistry and biology associated with magnesic soil. So it might be worthwhile, Brendan, catching up with Jason at some stage and just sort of gleaning some of the mechanisms there that he's trying to understand.
Yep.
And certainly organic amendment and gypsum are the 2 key treatments that he's using for the magnesic soils.
Yep. All right.
Thanks, Lucas. And also Dr. SN Tavakoli?
Tavakoli, yep.
Yep.
So his work is mainly field-based,
Yeah.
but he's involved with Jason's project as well. But Ehsan and Jason work quite closely together. But the mechanistic project, which is under Program 4 of the Soil CRC, is being led by Jason.
Yeah. Okay. So Dr. Ehsan's got new products for subsoil constraints. So that's more under the organic amendment type work.
Okay, so that's a separate project again.
Okay.
That's under Program 3. So they're looking at again, and I don't know if he's focusing on magnesic soils here, but he's certainly looking at submicron organic calcium products for sodic soils in particular. One of the issues with lime, for example, is it's not particularly soluble, and it takes a long time, if ever, for it to move through the soil profile. So they're looking at submicron organic lime products and possibly gypsum products as well. So you can surface apply, and then with rainfall, you'll actually get movement and dissolution down through the soil profile. So yeah, there's a fair bit of technology, sort of that nanotechnology going into that project.
Yeah. Okay. Yep. Great. Yes, Richard? We can't hear you, Richard. No, you're still on mute. Now.
Can you hear me now?
Yeah.
Okay. Brendan, did you have a look at doing any correlation with a penetrometer into those various gypsum trials, strips, compost strips, and in the deep ripping, just to see if there was anything in a relationship with the penetrometer giving you readings on the EM38?
No, I haven't. That's a good suggestion, Richard. I might take that on board, because we had recently done some work looking at, I guess, compaction with wheel tracks. So yeah, no, but yeah, good suggestion. Hadn't thought of that.
Thanks, Richard. That's great. Any other comments or questions for Brendan?
I had a question. I thought it was a really cool presentation. I was just interested because I'm actually going to talk about some of the deep ripping that has been happening in my region on a similar idea of about getting more water into our soil. And I was just curious as to what you thought, Brendan, was the difference between where you mentioned the deep ripping versus not deep ripping, where that moisture difference, how that came about, like why was there more moisture in that profile that didn't get ripped versus the one that did?
Yeah. The only thing I could suggest, Tim, and certainly that's why I brought it up, I guess from our neck of the woods, when I say my neck of the woods, it's, from Gunnedah North. So we're talking about some heavy grey, black cracking clay vertisols. So you could imagine, and the amount of cracking we've seen over the past 2 years, compared to probably your environment, where you probably don't have as much clay in the soil, and hence you don't have that cracking that we see. So I guess where in those trials where we haven't touched it, we've had that natural cracking, and then the rain that we finally did receive between the months of January, February, March, which was some damn good rain, don't get me wrong, but it came down fairly nice, consistent rain. We just seem to have far better fallow efficiency, I suppose, where we just left it compared to where we had deep ripping. And no doubt, where we deep rip, we naturally obviously break the soil up even more and expose it to even more air, and hence dry it out even more, which you wouldn't think is possible given how dry it has been, but obviously it has dried out significantly more. So whether it's a combination of drying it down even further, and then on top of that, it just doesn't seem to have the same fallow efficiency as it would have if you just left it naturally. So there could be two parts to it, I guess, Tim. I don't know. But I guess all I'm interested in is the benefit, I suppose, of doing nothing compared to deep ripping.
Yeah, definitely. And I think maybe that's where the difference in situation is, because I'll talk about it like a little demo we did in I guess my presentation, but we have like areas around Warren and near Coonabarabra and that sort of thing definitely have high levels of clay, like really black vertisols. But we had also a lot of wind erosion, as you guys probably did as well. And so a lot of our cracks were filling up with dust.
Yep.
And so those cracks, even though they were forming as the soil was drying out, were also getting filled. And so when we had rainfall, we just had a lot of runoff and not much infiltration. And so that was probably the issue we were running into a lot. And so that's why people were turning to ways to open up the soil again. But I think I'd really love to follow the project you're doing and see how that travels.
As I mentioned, we've actually another 4 sites. So this, as I say, this was not really a deep ripping trial by any means. It's more a soil amendment. It's just that was a very easy take-home message out of this trial for this today. But in addition to that, I've got another 4 sets of data which was set up specifically for deep ripping, and they're all telling the same story with an EM38. So in each and every trial where we had deep ripped, the EM38 readings have been significantly lower compared to where we just left it.
Brendan, I'm wondering if the lower EM was due to perhaps a lower bulk density in the rip soils as well. So I'm thinking it might be worth considering doing when you're taking the soil samples there, doing the bulk density, at least in the surface soil at the same time.
Yeah, so I'm just trying to think about that from an EM. What does, yeah, okay, so that would have an impact on the EM38 conductivity reading.
So lower bulk density, yeah, basically everything's further apart, therefore your conductivity is lower.
Yeah.
It might not necessarily be total water content.
Yes.
It might be due to the fact that the soil is actually lifted up, and you're now measuring actually a lower amount of solid material because it's a lower bulk density.
Yeah. No, good call. And that's a, you know, I know EM38 is not the be all and end all. It's just a part of the equation, and certainly that's why we're, you know, definitely going to be taking it through with the next, you know, 3 crops or over 5 years, because ultimately that will tell the story.
And did you have a question?
Yes, I do. Thanks, Felicity. To Brendan and also others that are managing verticile soils, I'm at Moree and cover a lot of country that's black verticile soils, and even on our own property we have them. It's interesting the observations that we've made over the last couple of years when talking to a lot of people in the region, that our soils haven't naturally cracked like that they have done in the past, even in pasture country as well as cropping country. And even to now, we're probably sitting on about 200 mils of rain, so we've got no chance of you know, getting a winter crop in here. But there are patches obviously around the region that have had storm rains and that they are planting, but we're still not seeing that open cracking that we used to see in the past. And I'm just curious to find out whether you've seen that or observed it, and what would actually be causing that.
Good question. I only speak on from what I've seen, and I don't know, I've seen some mighty cracks over the last 18 months.
Yes, and ordinarily we'd see it here too. You wouldn't be able to ride a horse across country or a bike, whereas we just haven't seen that natural cracking that we would expect of our soils. Yeah. Whether it's that dry that it's just not responding, I don't know.
Yeah, I would suggest the opposite. I thought I've seen some cracking like I've never seen before. So,
okay.
I probably just also could point out that like my family owns some heavy clay country just south, like some verticile country just south of Gilgandra, and I got a pretty annoyed phone call from one of our spray rig contractors about how many holes he was finding across the paddock.
Yeah.
So I think it's very probably region dependent or area dependent, but yeah, where we haven't seen many cracks, a lot of it's been filled up with dust. And then in other areas, we found a lot of quite large cracks, like sinkholes even, where soil's moved quite a bit.
So landscape dependent, and obviously there's, you know, you've got a lot of history in terms of floods or limited flooding, a whole range of history, I suppose, that impacts those particular landscapes in different regions as well.
Yeah, yeah.
I should also mention that in our area, some parts of our region are sitting on almost 500 mils of rainfall so far. Like we're probably the second wettest year up to date in the last 70 years.
Well done.
I don't know. We must have danced a bit hard. I don't know what happened, but it's unprecedented how much water's dropped in the last 2-3 months.
And I understand, Brendan, I'm not sure if you've been to Walgett or not, but it's that wet in places between Walgett, Rowena and Burren that they may not get a winter crop in. They're pulling tractors out of bogs. Yeah,
no, you're right. And as I say, the first trial we set up in 2016 at Burren Junction with one of the growers there. You remember 2016 was a full profile of moisture. They planted a cotton crop. The day he planted it, it never rained since, and he put the cultivator through the cotton, and he's never had a crop in that paddock since until this winter, hopefully. So hopefully after this winter might be the first data we get from that trial we set back up in 2016.
Yeah, no, it's certainly been ordinary, but anyway.
Terrific. Thanks very much, Brendan, and thanks to everyone for your comments and questions. That's really great. Have a look in the comment in the chat box to Brendan. There's a few comments there, and yeah, we'd be interested to see some results from the Burren trial if that's going to continue over the next couple of years to see how that goes. And I guess something from the south. There's been some work on deep ripping down here, and we've found that it's quite the results regarding benefits are quite rainfall dependent. So, you know, in the high rainfall zones, medium to high rainfall zones, you're getting quite good results, you know, yield results from deep ripping, but in the sort of medium to low rainfall zones, it's actually a yield penalty as well, and I think it's to do with perhaps some soil structure destruction and evaporation happening, opening up the soil and losing a bit of soil moisture. So yeah, it's interesting, but I'm still yet to be convinced on the economics of it in regards to, you know, like maybe now that oil prices have dropped a bit, the deep ripping is perhaps coming into a bit more economical. But I know I was talking to a landholder and he was using an enormous amount of fuel per hectare to deep rip to, well, nearly to 30 centimetres, and I just, you probably have to spread that over a couple of years to get get the money back on it. So anyway, it's great to see some work being done in that space anyway. So, and I think it's important to say horses for courses and very soil type specific and rainfall sort of area specific for that sort of work. But it's good to see it being done across the board. So. Thanks again, Brendan. Now what we might do is just have a 10-minute comfort break, get up and have a bit of a walk around, grab a cuppa if you like. I'll keep the meeting going, so if you want to chat amongst yourselves, feel free to. But I'll be calling on perhaps Tim if you want to get yourself organised, and so perhaps at about 10 to 11, Tim can kick us off next with his talk, but I'll let you guys have a bit of a break, and we'll see you in 10 minutes. Thanks all. All right, looks like we're all nearly back in on board, so just keeping time in mind. I don't want you to be sitting here all day, but we still want to make sure we get through what we want to. So I'll invite Tim to share his screen if you've got something to share, Tim, or just have a chat to us about what you've been up to. Tim, if you're speaking, you're still on mute.
There we go. Sorry about that. I was trying to find the unmute button. Can you see that Climate website? Cool, right. I just wanted to provide a bit of context. So just to show the situation that we found ourselves in within the Central West. So like everyone else, or most people, we've been in drought for at least the last 3 years for the majority of the region, with people being much longer than that, up to 6 or 7 years since they've grown a crop. And so we have quite bare soils, a lot of wind erosion has occurred, and so yeah, a lot of our topsoil has been lost. And so a lot of people were worried about this coming season as to what kind of rain we'd expect over the summer and what that rain would do, whether it would go into our profiles or whether it would run off, as we've seen in previous years coming out of drought. My boss talks about, she loves her soils and soil science, and she goes on about how it's when we finally get rain, that's where we lose a lot of our soil, particularly our topsoil. So this is just showing Gilgandra, which is in our area. This is this current year in the red. So you can see our average rainfall for the entire season is generally 400 mils, and we're currently sitting at 400 mils for the Gilgandra area. And so it's been very intense rainfall over the last few months. Fortunately, it's allowed us to have a winter crop. We'll go, and everyone's mad with sowing and spraying at the moment. However, a lot of the people have, particularly further east where they've got more rainfall, have reported that rainfall has filled up their dams and basically run off, and they haven't seen it infiltrate into the profile. So that's kind of the question that's context, I guess, we were looking at. The next thing was we were talking to a lot of our growers, and they were saying that they were deep ripping. And so we were like, we're seeing a result, what's going on? And they said anecdotally that they had less runoff where they had deep ripped with these heavy rainfalls compared to where they hadn't. And so we wanted to provide some context to that, some information to people who are thinking about doing the same, whether that was a good idea or not. So we kind of came in with our eyes closed so that we had a good, I guess, we didn't have any bias one way or the other, but we have a rainfall simulator. And so we just, that can output 50 mils an hour. And so we got one of our growers who was doing this at the moment to do it on 2 soil types, and to kind of compare where he had bare country that hadn't been cropped in the last 3 years versus country that he recently deep ripped to 350 mils, to see whether more, and we could capture how much was running off versus how much was going in, so we knew how much was infiltrating, and then we could present that to growers. So this is part of what we call our ADAPT project. And I'll just make sure, is my video popping up? Rainfall simulator? Yeah. So this is our beautiful rainfall simulator trailer that we've had wandering around the Central West. And like I said, it can output 50 mils an hour. It just like pulses water out. So there's a big, large, I guess, well, I think we can hold a few hundred up to nearly 1,000 litres. And then we have, you can see like there's an air pump that any runoff is captured in that little square. And then we can kind of measure that. And we did it over 15 minutes. So we can times it by 4 to work out how much is falling in an hour. And yeah, so we compared deep ripping versus not in deep ripping on a vertisol and a red chromosol. And this is near Mendoran, which is kind of a bit further east of Gilgandra in the Central West region. And I'll just see if yeah, so I'll just kind of talk over it. There's no sound, but just to kind of show you, and this is kind of the approach that we had, in that we found if people just see what was going on, as opposed to us talking about it and that sort of thing, it might be a bit easier. So this is kind of the situation that he had, a lot of erosion. And so we just put a bit of a metal square, and that would fall in there. And then you could see there's like a gap on one end. And so it would naturally run off into that, and we could pump it out. And so you can see the pulsing and the work that the staff and the farmer are doing while that's happening. And it's slowly starting to pull up. So this is where no deep ripping had occurred. And so a lot of that's pulling on the surface and running off, and then being when it's in the runoff chamber, it's getting pumped out. And that was the runoff that occurred, those two together, in 15 minutes from that site when no deep ripping had occurred. So just a bare country with minimal slope. And then, so I'll go back, it's just skipped ahead. Right, and now we compare that against the same, so just literally a couple, 2 meters over where he'd done a few lines of deep ripping to 350 mils. And we did the same process again. And as you can see, there's a little bit more roughness on the soil, so it has a bit more time to lay there and infiltrate, and also it's just opened it up quite a fair bit. And then that's the runoff that we, in the same amount of time with the same amount of water, that's how much runoff we had in the same soil type. And so I guess the question that we're looking at is, that's why I guess I mentioned it might be a little bit of a different situation with the debriefing, because we were getting really heavy rainfall. And if we didn't get that in our soil, it was a bit wasted. Like if you had, obviously had dams and that sort of thing, that's really beneficial for stock and just water resources. But in terms of growing crops and trying to get money back in the system, we need water in that profile, because obviously water equals money when we're talking about cropping. And then we did the same process on a red chromosome, which was probably, yeah, a lot more pooling, that sort of thing, because there's hard setting on the top. So this was the unripped portion. And then, yeah, so a lot more runoff on that soil type. And then we did the same deep ripping. And I think this was probably more of a case of it was a lot rougher, like the soil was rougher on top, so the water had more time to sit instead of running off. And so that pooling, I think, aided quite a bit. So yeah, there was barely any runoff from that. So yeah, so that's kind of what we did as a bit of demo, and we took that to the GRDC update in Dubbo, which is one of our bigger cropping agronomy events, and kind of displayed that and talk people through that and try to give some perspective on what the goals are and then talk about what kind of situations that this might work with. So obviously we worked in a black vertisol. It's probably pristine cropping country, the best. That particular paddock is probably one of the best we have to offer in our region. Red countries and chromosol is one of the better red soils that we have. But in the Central West, we also have very bad salinity issues, like natural salinity issues, and a lot of sandy soils. So we weren't recommending the same practices in those, and trying to give some, yeah, like I said, perspective about what soil types you probably do this in, what situations where by opening up the soil where we didn't have anything in the profile, we really didn't have much to lose anyway, except diesel and costs, that sort of thing. But the fact that we can get more water into the soil versus just running off and not making use of it, that's where we saw the benefit. Yeah, so a lot of people were doing this already. We just wanted to provide some information on it.
Excellent. Thanks, Tim. How deep did you rip? Sorry, you might have said.
350 mils.
Yeah.
So a fair way.
Yeah.
And what was the time spacing, Tim?
410 mils.
And what would you sow on? You'd sow on less than 410, wouldn't you?
Well, there's been some research based out of CSIRO and New South Wales DPI, as well as Queensland DAF, which has looked at particular regions, like areas across our region, of what kind of moisture you'd succeed in. So with us, we can kind of get from Gilgandra, which is kind of in the middle or towards the east of our region. If you had 100 mils, then you'll have a 10% chance that you're going to lose that crop at the start. Yeah, so that's probably pretty what we'd expect to go on, because we're more of a winter dominant rainfall system here. But as you go further north, it switches into that summer dominance.
Yeah.
We kind of have the benefit of having towards the south, having a lot more winter rainfall, than as we go further north, a lot more there's quite a distinct difference. But yeah, about 100 mils or 150 mils. Personally, with our cropping that we do with my family, if I can get my really this beautiful thing down the whole way, then I'm pretty confident that I'll have a good half decent. I'll pay my cost anyway.
Hey Tim, do you have the amount of runoff off the chromosol was pretty high? Do you have a ratio of what went into the soil versus what ran off?
Yeah, so that rainfall simulator can output 50 mils an hour. So we ran it for 15 minutes. So
like 12 mils perhaps, would you have put in 12, 15 mils?
Yeah, so I guess in that instance, yeah, I should be able to, 12.5 mils every 15 minutes it was outputting. And then I guess you have to work it over the area of the square as well.
Yeah, you have to work it over. Yeah. Basically what you're asking is a fallow efficiency.
Yeah. In the areas where we did have the deep ripping, obviously we had minimal. So I assume we get at least 10, close to that 12 mark, but then you'd have to incorporate some evaporation. But I haven't calculated at the moment, but I definitely could do that with the information that I did gather. But it wouldn't take me very long.
Bit of homework, bit of mathematics.
Yeah, keep me busy during COVID.
Lucas, is there any work from the Soil CRC in relation to this project? I guess I'm just looking at some of the list here, looking at, I'm not sure whether it's relevant or not, the soil functional resilience. Is this sort of relevant?
So the functional resilience is a little bit different, but there is some work around non-wetting soils in particular. I don't know if the chromosol there is non-wetting. I don't think it is. It's probably more just hard setting rather than non-wetting. But there is a lot of work on sandy, in particular the sandy non-wetting soils, looking at products and practices like deep ripping to increase water infiltration. I don't know if you're working on hard setting soils per se.
Yeah, that's okay.
Is that talking about hydrophobic soils, like with lipids and that sitting on the soil surface? Yeah,
so soils that once they dry out, the microbes generate sort of waxes and other compounds that then protect them, but they also mean that the water can't infiltrate into the soil. So the water just sort of beads on the surface and then runs off before it actually goes into the profile.
Yep.
How long after, Tim, did you apply that simulator? So how long after your deep ripping treatment did that happen?
I think there was like a 50 mil rain event in between. So you're
talking weeks or months though?
Weeks.
Oh, weeks, yeah.
Yeah, so the farmer, he did some deep ripping on a paddock, and then he sent me a video of one paddock next to another and the amount of water running off one versus the other. And so he wasn't the first one to kind of talk about it, and so we figured we'd provide some information because we had that rainfall simulator, and basically as soon as that happened, we were able to get on the paddock when it was dry enough.
Yeah.
The other thing to look for in the future, Tim, would also be the effect of stubble retention as well. So how much stubble is retained and how is that managed on, and how does that then impact the fallow efficiency and water infiltration? And
I think that was also part of our conversation with growers, in that it didn't take away from any of the work done in terms of stubble retention. So a lot of our cropping systems rely heavily on stubble retention to improve that fallow efficiency. It was more about the fact that in the last 3 years we hadn't been able to generate high levels. You didn't have any, stubble. Yeah. So what when your hands and legs are tied together, what's your last ditch option, and whether this was good or not.
Yeah.
Strategic.
And this whole thing of deep ripping, it's very interesting. I suppose initially we're all just thinking of soil water and, you know, hopefully improvements that it may or may not bring. But there's so many different facets to this deep ripping. That's why we're looking at it from a longer term basis, you know, whether it is just a physical aeration of the soil, breaking up compaction layers, who knows what stimulating microbiology, we've got no idea.
Yeah.
What you're doing.
SR Tavicola's got some great great photographs again where they've deep ripped and they've had a look at the roots, the wheat roots penetrating down the rip line, and yeah, it's quite amazing how much deeper into the profile they venture through the rip line.
Yep. And who knows, that could be a part of the crop response. It may not be that there's any more water, it's just that the plants can actually access more water in the profile because it can go deeper.
They can go deeper, exactly.
And nutrients. I guess it's the, so we're seeing some 1 or 2 year effects. What happens, you know, once you've opened that soil up, is there then some sort of collapse that happens that then creates like a reversal of what you've just, you know, some of those benefits, short-term benefits, and then if we're driving over and that sort of thing, if there's some sort of collapse of the soil structure that happens that then negates those benefits.
Yep. That's something which we're very keen to look at. I suppose I refer to it as reconsolidation of the soil. So in our mind, you know, we need to ask the question, why would we go and spend a whole lot of money in terms of diesel and fertiliser to put something at 25 centimetres in depth, where in 12 months' time, if the soil reconsolidates and the plant still can't access it, what's the point? So we don't even know that yet.
Mm-hmm.
You know, it's going to depend on the soil structure, where you are. You know, some soils are just going to reconsolidate. You know, who knows, within months.
Yeah, it's a good point,
I don't
Brendan.
know, years, I've got no idea.
Yeah, but also where you do have more roots going down into the profile, potentially there you've got improved soil stability and maybe, you know, improved aeration and macro pores developing through the soil, through the activity of roots in that
Root
rip
system.
zone. So I personally suspect the effect is longer than 12 months, but I don't know if there's evidence to support that.
And I'm considerate of what Tim was talking about in regards to some of those areas which may have some salinity issues, and being conscious of what you're working with, and do you want to actually encourage the roots to go down deeper? Is it worthwhile, or is it hostile down there for them to go down, sort of thing?
And I think that's the fine line that I've been trying to walk lately, is trying to provide all this context around our video so that it doesn't give people a license. They feel like we give them a license to just go out and cultivate every year. Because we have extremes where people are using speed tellers every season for weed control, as well as to create that fine tilt. But at the same time, we've also got people in very sandy scenarios where, I think there was a paper I read that 10% of any deep ripping you do, 10% of that subsoil gets brought to the surface. So if we're bringing very high acidic soil or very high salinity soil to the surface and reducing establishment and that sort of thing, then yeah, it's definitely not, that's a great disadvantage in our cropping system.
Terrific. All right. Thanks, Tim. That was great. Yeah, have a look at the chat box. There's a few comments there. We'll keep moving along, and Jasmine, would you like to go next if you're ready? If you're not, you can say you're not.
Yep, I'm good.
Great.
Hopefully this works. Sorry, got computer screens everywhere. I don't know. That worked at all? Is that brought
Did
up?
you hit the share screen?
Yeah.
Yep. Can't see it yet. You've got to choose the screen that you want to share.
Ah, right. Okay.
So when you hit share screen, it'll come up with some options. So just choose the screen that comes up with that you want to share.
Oh, okay. See if this is going to work. Yeah. Haven't had to share a screen before, so this is definitely new.
That's okay. It's all good. Yep, it's on its way.
All right, cool. Sorry, I keep losing my mouse.
I know, it's a test, isn't it?
Yeah.
That's okay. Now you can make that into like a slideshow if you like, so then we can see sort of like the full screen. Yeah, beautiful.
All right, cool. So I was just going to sort of touch on a couple of different projects because we have quite a few sort of just in the works at the moment. So that's just a quick overview of the Burdekin, probably an hour south of Townsville, North Queensland. So it's a somewhat decent sized area. We've got 80,000 hectares of furrow irrigated agriculture. And we have quite a few different ranges of soil types. So we have a lot of lighter delta sort of country over here and a lot of heavier sort of clays and yeah, cracking clays, magnesic soils, that sort of stuff sort of out the back, heading west. So there's a couple of soil constraints that we have, particularly to do with irrigation, since it's a heavily irrigated area. So we can have issues with lateral soakage, water logging, deep drainage as well, and some of the irrigation water can be quite poor, which also affects the soil quality as well. There's a couple of patches around, well, not a couple, quite a few areas where we do have quite sodic soils. So ESPs of over 6%. I've seen one that was ridiculous, like 20%, which pretty much shouldn't be growing anything on that. But yeah, there is quite an issue with that. There's a few trials that we're looking at doing where we actually do a range of the gypsum applications, possibly even a combination of lime and gypsum. Just sort of depends on what the soil test comes back as. Naturally, the Burdekin has quite a low organic carbon. Yeah, 0.4 to 1.2 is pretty typical, averaging about 0.8% of organic carbon. It's quite difficult to increase that as well, given we're in a tropical environment. Yeah, just generally soil health probably could be something that we could focus on. Got a few trials involving that I'll talk about later. Compaction's a big one, especially in your heavier soils. Big machinery moving over that. Yeah, and row spacing as well can really impact that. And yeah, a bit of salinity as well. Some soils EC of over 1.5, especially around the coastal areas where you can have rising groundwater. We have a big aquifer here as well, so a lot of people pump out of that. So that can differ in different areas. So one project that's, I can't remember how many years it is, Richard would probably know. So I'm not involved in this one. I'm speaking on behalf of some other people here. We've got the Soil Health Project. So that's partnered with SRA, HPSL and Ingham, DAF and University of Queensland. So there's 3 sites in the Burdekin, and it's pretty much looking at improving farming systems, particularly with productivity and profitability being looked at as well. So they're quite large plots, big sort of demonstration sites. There's different applications of mill mud. So there's a couple that are quite deep. I think it was 600 mil, something like that, of mill mud at depth, and seeing if that stays in the soil profile and helps with the sugarcane or beans or whatever it is that they're growing. I think there was surface application of mill mud as well, and then a combination of deep application mill mud plus mung bean or soybean crop, and then vice versa, just a combination of these types of things. Yeah, so that's currently happening. I think it'll be going for another 4 or 5 years at least, so it's a decent length project. There's a couple of companion cropping trials as well. So looking at mung beans versus tillage radish versus mung beans and radish mixture and a control. Then there's also soybeans, mustard, and a soybean mustard mix. I think we've also just set up one with peanuts as well. So yeah, really looking at trying to, I guess, sort of help open up the soil. So these are one of the trials, particularly the tillage radish was in, I think, quite heavy country. So it's trying to open up the soil to try and get some sort of, aeration and just infiltration there. Project Catalyst, so I'm involved in this one. We're actually sort of, the broader adoption validation trials are pretty much looking at what the grower's interested in and applying it to the farm. So quite a few growers have expressed interest in legume crops or just some sort of mixed species fallow. So, well, one of the other ones I'm also looking at is applying molasses to the soil to try and help with parasitic nematodes. So in the lighter country, the nematodes tend to affect the roots quite badly. So we're looking at trying to improve the soil structure and possibly sort of providing a food source for other organisms to hopefully counteract the negative impacting nematodes. So that's in the process at the moment. There's one interesting one. We've got a mixed species fallow and it's also involving cows. So what this guy is doing, he's going to grow I think at least 4 or 5 different crops. So it might be sorghum, we're trying to get some sun hemp, some sort of legume, and maybe radish, I think it was, radish as well. So he's just going to spread that over the soil, let it pretty much come up, and then he's going to get some cattle in there. They're going to go in there and intensely graze it, poop and pee all over it, and yeah, I guess squish all that stuff in. What we're going to do is hopefully do some biological testing there and also some penetrometer stuff as well, seeing if the compaction from the cows is, you know, what sort of level that's at. But yeah, trying to improve the practices from just like a bare fallow, which, you know, hasn't got many benefits, to something quite complex. So we should find some interesting things from that. Yeah, a couple of growers I'm working with, we're just implementing fallow cropping for the first time, not particularly for financial gain, just for soil health benefits, which has been really good. And yeah, like I was saying, amelioration trials, so looking at a combination of lime and gypsum or just gypsum, possibly at different rates and maybe different depths, like over broadcast or incorporated. There's also green waste trials. Unfortunately, I'm not a part of this one, but I have done a little bit here and there. So it's a collaboration between HCPSL and the Townsville/Ayr City Councils. So it's pretty much getting the green waste from those entities and then actually putting it into the paddock. So it's all dried, it's all mulched up. And what we've been doing is combining either the green waste with mill mud and putting that into the soil, or mixing that with some sort of compost, and then planting beans over the top. I think one of the trial sites has soybeans over it at the moment, so we're doing analysis on the soybeans to see, you know, if there's variation across the block in the different treatments, and also I think they're going to look at a little bit of biology maybe, but yeah, so some interesting things happening, particularly in the fallow cropping space, which has been pretty good. So yeah, I haven't got too much to talk about there, but that's yeah, a quick of what's happening.
That's great, thanks Jasmine. I had a question about the mixed species. So will the companion cropping, will they be harvested you know, for sale, or is that a bit like your legumes for soil health?
Sorry, the mixed species fallow?
Yeah.
No, so that's just going to be used for, I guess, fodder for the cows, because of, with coronavirus, the grower was actually sort of assessing whether, you know, selling the cows off now or trying to keep them until maybe next year, but reducing his costs for actually providing feed. So he was going to just grow a whole bunch of stuff, let the cows in and just eat all that, whatever's come up. And then, yeah, just keep moving them around the block. So it's providing a food source for the cows. So,
yeah. Okay, and then there was another one called companion cropping, where you had mung beans and tillage radish. Would they be harvested, or?
Yeah. We have the peanuts being harvested today, actually. And I think the beans were yesterday. Tillage radish, I think that may have happened last year. Again, I'm not involved in this one, but yeah, I think the tillage radish was done last year, end of last year. Yeah. Yeah.
Great. Yeah, I was just having a look at the project list, and you guys are involved in quite a number of projects with the soil CRC, which is fantastic. So we'll be interested in yeah, hearing a bit more about those ones. Does anyone have any questions or comments for Jasmine?
Yeah, I guess I was interested in I guess what sort of assessments, Jasmine, and how long are you looking at? Obviously yield, over how many crops, over how long, and what other types of testing? You mentioned something about biological testing. How do you do that?
Yeah, so with the biological testing, we are sending them to the University of Queensland. Yeah, so from my understanding, they do quite a number of tests looking at enzyme activity, nematode counts, something to do with carbon dioxide as well. Can't remember all of them off the top of my head, but yeah, there's a few different tests they do there. So yeah, I think we'll be trying to do that biological testing, particularly for the mixed species fellow with the cows. Well, the other trial sites, I think it's probably not as much, say for the green waste trials. I think it's more of a minimum sort of biological, just having a look at generally what's there. Yeah, what was the other question, sorry?
Oh, I guess, what's your assessment? Are you taking, you know, the next 3 crops to yield, or how are you going to justify your treatment list, I suppose? What's the plan?
So yeah, the beans at the moment, like for the green waste trials, we've just got the legumes in as a fallow crop, and then it'll be going back into sugarcane. So for those trials, I think they will be harvesting the cane and looking at tons of sugar and tons of cane, I think. For the mill mud, the soil health project, I believe the same thing will happen. If there are beans and they're harvested, they'll look at the grain, and they'll also look at the sugar cane after that, however many years they're going into the project. So yeah, looking at the yield and sugar content as well.
Yep. And just another one, more of a practical one. I saw a photo there of a big thumping wide trench with a heap of mill mud in it, I'm assuming. How on earth do you get that much product down a trench? What machine?
Yeah, so pretty much they got, I think it was a massive trencher. It's really not economical to do it.
Right.
But yeah, it was a big trencher. It took ages to do it. But yeah, 600 mil deep, and then just loaded it in there. Yeah, you probably wouldn't do that practically, but it was just for experimental, and I guess if it happens to work, maybe we can look at creating equipment that could maybe do that a little bit better.
Okay. So commercially, guys up there actually deep banding mill mud commercially? Is that a practice commonly happening or not?
Currently, I've only been here for 3 years, so when I first started, most people seem to be applying broadcast mill mud, but recently, probably in the last year, 2 years, people have been band applying, so around the stool, or not applying, definitely not that deep, maybe, I don't know, 10, 15 centimeters, something like that. So they are subsurface applying now, and finding benefits with that. Yeah.
Okay. So I'd be really keen to see some photos of a machine that physically can apply that product.
Yeah.
We've got some huge interest in trying to obviously apply compost and gypsum, but just being a machine that can handle those products deep is just a nightmare, particularly what point of view.
Yeah, definitely. Yeah, and trying to get it evenly spread is not easy.
That's a nightmare.
So, Brendan, could I just respond to that question as well? So, Essan Tavicoli and also Vic DPI have got, there are a couple of machines, basically deep preppers that can then deposit organic amendments, pelletized organic amendments. Don't know if they can handle like powdered gypsum, but they definitely do pelletized organic amendments at depth, and they're commonly applying them in their trials at sort of 40 centimetres deep.
Yeah.
So they are at commercial scale, but definitely for research purposes at the moment. But I think there are some manufacturers starting to look at those bits of kit seriously. So I can get some further information to you if you're interested.
Yeah, so Dr. Roger Armstrong at Horsham Research Centre, he's been working on those, applying deep amendments for 4 or 5 years, and I think he's got a couple of years left on a particular project. And Southern Farming Systems also have a, I think one of the original prototypes of that subsurface amendment application. Not exactly sure how safe it is. It's probably not super safe. And I also think John Fowler from New South Wales DPI has also been doing a bit of work again, looks pretty not safe, the machinery that they're using, but at least it would give you a bit of an idea about what it looks like and how it's worked, and the prototypes that they've used, I guess. But the latest and safest one is probably from Roger Armstrong at Horsham. So you could, yeah.
And that machine will be used in about 5 CRC field trials as well, in southern New South Wales, Victoria, and that sort of southeastern corner of South Australia as well.
Yeah, I think more higher rainfall areas, I think, is where they've decided that they're getting their best bang for their buck in regards to those subsoil ameliorants. Yeah. Anne, did you have a question?
Question for Jasmine. I'm just interested in the livestock component of the research that's being done, and just to specifically ask, I suppose initially, is it compaction that you're actually trying to measure?
It's a combination of things. I think mostly we're looking at just sort of getting the fallow crops established and looking at the biology, sort of the improvements in soil health there, plus the potential for compaction from the cows as well. So yeah, it's just a side note that the grower was interested in, because he didn't want to, compact it too much so that it's difficult for the sugarcane or anything like that, even though it's relatively okay with that.
Yeah, there's a lot of information about time grazing. So I would think that the compaction obviously would be directly related to your soil conditions at the time and also in relation to the actual amount of time that they're actually on that piece of land. So the idea with the time grazing is to move them on as quickly as you possibly can in high density situations. So at the same time, you're going to get the benefits of the manure and the urine. They're going to be trampled back into that soil. So that's very good. It'd be interesting to see the results from that trial.
Yeah, definitely. Thank you.
Good. Thank you.
Great, thank you, Jasmine. And yeah, have a look in the comments. I see Anne's made a few comments there, so have a little read of those. We'll keep moving on, and perhaps we'll stay north and in the sugar area. Richard, if you would like to give us a little update of what you guys have been up to.
Yes. Is it working?
Yeah, it's all good.
Yep. Good. Okay. I don't have a PowerPoint presentation. I just got a few notes here. I'm going to try and share it, and let's see what happens.
Okay.
That's not it. Can you see this?
Yeah, it's on its way.
Yep.
Oh, bless you.
Is it there yet?
Yes.
Okay. There's several different things I've been doing, and that over the last 4 or 5 months. One of the main things we've been looking at is a legume planting regime we're using up here in our fallow situations. And that for cane, we're predominantly a cane-based growing area, around about 65,000 hectares of cane, and annually we have around about that 6,000 to 7,000 hectares of fallow, which is terminated cane. So what we're doing, we're trying to get a major increase in the amount of legumes going out as a green manure crop. If you have a look, previously we've been getting around about a 5 to 6% going to green manure crops, legume mixed species, and in the last 6 to 12 months, we've gone from those 5 to 6 to a 25 to 30% fallow crop, and which is a major improvement. This year we went through approximately 50,000 kilos of seed, and that mainly consisting of Leichhardt soybeans, Rongai lab, cowpeas, and a small amount of sunflowers and sun hemp. What we've done a number of trials, and I have a number of growers throughout the district that we do what we call target fives. And there's 5 major areas in the district, so we've got 5 growers in those areas. And what I do, I get those fellows to plant a legume crop, and that with our assistance using equipment that we have available. And we'll plant that up, and then I will run workshops at those particular places there with another 5 or 6 or 10 growers that are in the immediate area that have never done legumes before or never played in this situation before. So we go ahead and we do that there. And it's just a pretty casual sort of an afternoon. We normally start about 4 in the afternoon and finish around about 5:36. Have a beer or 2 and a sausage, and just sit down and talk about everything that's going on in the crops and what to look for and what's going on. So if you can see this particular photo here, that's on my particular place. That's a multi-species mixed fallow consisting of Leichhardt soybeans, your Rongais, your cowpeas, your sun hemps and your sunflowers. And that we had a group of growers from around my particular area come in and went right through the whole works and jerks. And we've taken that crop right through now to termination. This second middle photo here is nodulation of the rhizobia. That's only 7 days after planting. And that, yes, we had actually dry soil when we planted, but the day after we picked up around about 50 to 60 mils of rain. So yes, we had a good germination, and that, as you can see by those results. And if you look at the third photo, you actually see it looks like a jungle actually. The sun hemp grows up to around about 2.5 metres. There's sunflowers in there, and you can actually see the cowpea and the lab starting to climb up over top of the sun hemp and the sunflowers, and that is exactly what we want. We terminated that crop at 72 days, and that got terminated, and that sprayed out with a glyphosate 2,4-D Starane brew, and that's just sitting there now as just dead rotting trash, and we're just waiting on soil moisture and rainfall, because we're getting a little bit of rain now, so we don't want to touch it. And then that will be incorporated slightly, and that will go through twice with what we call a bed renovator, and that'll chop it up and incorporate it back into the soil, and it'll leave us the little bed like over here, and we'll actually plant the cane straight into the top of that. The results are there's been bioassays done in here, and that on biomass, and that and other trials we've done nematodes, and we're also looking at soil health as far as the flora and fauna and the VAM, and we're also looking at the response the cane crop comes to afterwards, and that once it's harvested 12 months after we planted, because they're a 12 months crop, and from there we'll actually get an idea of the response that we got out of the legumes as far as nitrogen goes. And from the previous trials that we have done, we have a normal annual application of nitrogen in plant cane around about 130 kilos of N per hectare. And we find out after a good legume crop, we can drop that down to 40, 50, 60 kilos of nitrogen of fertiliser applied. So there's a major saving there, because one of the major problems that we've got to look at in this particular district and anywhere growing cane on the East Coast is runoff, and that going onto the barrier reef. And that's one of our biggest headaches. We have a lot of legislation that control what we do and don't do, and the amount of fertilising that we do and our herbicides that we're using and a whole gamut of things like that. So yeah, if we can reduce our nitrogen down, that's a good response. We're also, our soil health is improving, and that our soils become more responsive. They become much easier to work, and we're going onto a controlled traffic situation, and that we're only going through with GPS and just travelling only where we need to, right from all our row crop machinery through to harvesting, and that is all GPS controlled. And with that there, we're trying to have a compacted area only in one spot, not over the whole paddock. Some of your broadacre fellas might not quite understand how the cane situation works. We're on a 1.6 to 1.8 metre rows. So we have a harvester weighing around 22 tonne, travelling up and down every row. And that's on a 1.8 to 1.9 metre wheel spacing. Then we have haul outs that travel up and down the same rows. And they're probably carrying 24, 25 tonne. And that's how we end up with massive compaction areas, especially up here in the north where we have normally a reasonably high water or soil moisture content. So compaction is fairly high. So we want to control that to a certain percentage of the paddock and not expand it. In other words, what we're trying to do is make our rows into a bigger bucket. So we're not, we've got better root systems growing, and we can go through there after fourth or fifth return, because cane, we cut it off and it just keeps growing back up again like a weed. And yeah, we can go there fourth or fifth return and go through with penetrometers and that, and bury them down to 750 mils and not have any pressure readings above 2 to 2,500 kPa. We know above 2,500 kPa, we're starting to get root and worm inactivity because it's just too hard for them to penetrate. So that's the whole thing that we're trying. In the interrows, and that we may go down 5 centimetres. That's it, and that with the compaction area that's there. So that's the sort of stuff we're looking at, and we're doing all sorts of trials into that. And this is also part of the SRA soil health project that I'm tied up with as well, the same as Jasmine down the Burdekin. We're doing the same sort of stuff. We're doing like the multi-species. We're also doing mill mud at depth, and that's furrowed out to around about 35, 40 centimetres, and that with a set of discs, and that dual disc, they will just furrow it out. We come behind with an applicator, drop the mud ash products in, and we're even doing green waste material in there, composted. The mud ash goes in around about that 40 tonne a hectare, and then it gets covered over and left, and the green manure crops generally planted on top. The green waste stuff that we're doing at a Townsville City Council goes out around at 15 to 20 tonne a hectare, and we also plant over top of that there with legumes as well. This year we've had I've worked with Sunrise out of the Burdekin, Peter McDonald, and that we've planted around 200 hectares of rice, and that non-paddy rice, and that because we can grow that up here without having to have irrigation paddies, unlike the Burdekin and further down around the Riverina areas. So far, we're averaging around about 3.5 to 4 tonne per hectare. We are also at the moment getting a large number of what we call flatheads, and that in our rice, which is unfilled grain, and that because we've had a light, uneven wet season here this year. We've picked up probably 3 lots of rain, but they've been fairly high amounts over a very short period of time, and none of them actually been right at the end in the grain fill section. They've been earlier on. So our moisture levels and that were a bit low. On a normal year, we would have nowhere near the amount of flatheads and that coming out of our rice systems. And that, so it's something that the year was kind, but it was unkind for rice growing. Yeah, as I said before, I do a number of on-farm workshops inviting growers along to have a look at fallow legumes, fallow cropping, the machinery, getting around it. And we have converted quite a few what we call newish type farmers, blokes that have been in the industry less than 7 to 8 years, and that onto controlled traffic systems, onto going to fallow legumes. And one particular fellow that we've started this with about 3 years ago, his production's just about doubled on the farm that he's got. He bought a really crap farm, and now it's one of the top producing farms in that particular area. And that just through the use of controlled trafficking and legumes, and that it uses a multi-species, and he just can't get over it. He does nothing. He runs cattle as a sideline. He's got a couple of thousand head of cattle and that as well. But he's got also a fairly large cane farm. So if he didn't go to those particular systems, he'd be having difficulties running both enterprises at once. Okay, and ACPSL, which is the company I work for, and we're involved in 8 different CRC projects, and that with Lucas and Terry Rose and Professor Chen, and that and Miriam and a few of the other fellows around the ridges. So yeah, we're quite involved, and yeah, it's a good turnout. The CRC, it's really helping us along up here. Okay, what questions?
Thanks, Richard. That's a great summary of what you guys are up to up there. So if they weren't planting those, you know, the legumes or the multi-species, would the paddocks just be left bare, would they?
Yes, they'd be going to what we call a grassy fallow, which means that they would just terminate the cane at the end of the year, which is normally in that November, December period. And that they would just disc them in, and it would just left, and there'd be just grass and rubbish and crap grow on it. And that would go through till this time of the year, around the May. And then it'd either be disced out, or a lot of blokes will go in with a glyphosate spray and actually spray it out and clean it up. And the results we get out of that isn't very great. There are a couple of growers that we'll leave the cane there and just let it grow, and they will spray it out probably around about early January, and just leave the whole stubble, the trash and everything just sitting on top of the ground. That's mainly in the areas where we have erosion, and that from floodwaters. That's to try and protect our soil and keep a good coverage on it.
Richard, so that mixed species cover crop, is that the one that you sent soil down to Mick Rose at DPI from that plot?
No, that one come from Lawrence's place.
Oh, right, that was from Lawrence's place.
Yeah. It's the same sort of mixed species.
Just a different location.
Yeah, just a different location. Yeah.
Yeah. So
I don't have any photos of his.
So one of the purposes of that particular project as part of the soil CRC is to have a look at the microbial resilience. So it's quite different to having a look at, you know, what species are present at a particular time. So it's a fairly sophisticated technique where the soils are placed under stress factors like compaction or drought. And the aim of that then is to see if, in this case, you know, that mixed species cover crop that's been rolled into the soil and incorporated in the soil is actually more resilient to these particular stress factors. And we're about 2/3 of the way through that assessment, Richard, and I think it's looking pretty good. And I think it's showing what you're anticipating it will show.
Yeah.
So that means it can actually function. The soil will actually function as far as phosphorus, nitrogen, sulfur cycling further into a compaction stress, or further into a water limitation stress than the standard fallow soil.
Yeah. Well, we've been doing a lot of trial work into mixed species and combination of mixed species over the last 3 or 4 years, and looking at the nutrient cycling that's coming out of it. And I'll talk about this particular crop here. There's the 5 species that we have in there. as you all know, your moringa, your calypsos and your ebonies are fairly quick maturing, climbing cowpea. And then you have the lab, the Sawyers. What we look at is there's 4 or 5 different maturity stages throughout that whole crop cycle. We have the moringas, or we have the cowpeas maturing first. And they give us quick coverage, and that early in the piece. Then we have the sunflowers and the sun hemps are pushing along. They're the tall, prostrate plants that allow the cowpeas to actually climb up on and they actually perform better. Then we have the slower maturing and the later maturing labs. And so when the cowpeas have gone through their maturity, the labs start climbing up and starting to take over. And we've got the Leichhardt soybeans actually sits underneath. You think there's none there until later on when the plants start to pull down all the tall crops and that, and you see all the soybeans sitting there. So we're getting a good diversity of different plants operating and growing at different stages throughout that very short crop cycle of 70 to 100 days. And that, and we're finding out when we start doing mixed species, especially with things like sun hemp and that, and we're finding an allelopathic effect with nematodes. And that, it's a biofumigant. So it's controlling nematodes. As you know, sunflowers will actually increase the amount of nematodes that you can have in your paddock. And the same with the rongai, they can increase them as well. But by putting sun hemp in it, we're not seeing those increases in nematodes. So there's a major advantage there. And we're finding out just with the whole mouldy species, we're actually getting different nitrogen release rates coming through it. One particular trial I done a couple of years ago was just a straight sun hemp trial. And we grew a whole crop of cane, plant cane, on 18 kilos of nitrogen per hectare total. That was it. And that, which is never heard of. And that versus our standard of 130 kilos a hectare. And there's only 4 tonne a hectare difference. When you've got 118 to 122 tonne a hectare, 4 tonne a hectare percentage-wise is not blooming much. And statistical-wise, there was no difference. And we carried that through into what we call the first return. And we went in with a 25 kilo of chemical nitrogen, and that into that same replicated trial, and that and up to 130 again in the normal treatments, because there was 4 reps, 25, 50, 85 and 130 from memory. And the 25 versus 130, there was around about 8 to 10 tonne a hectare difference, but we also had a bit of a flood problem go through that particular block. We had 700 mils in 9 hours of rain a few years ago, and it ended up with 2.5 metres of water over that complete block and just about drowned most of it out. So we don't know exactly how good or bad things would have been otherwise. But looking at it, we're getting longevity out of our fallow cropping, and that carrying our production through a lot longer.
Yeah, so Richard, clearly one of the benefits there of the large volume of cover crop is that you're increasing that labile carbon content of soil, and therefore also the potentially mineralizable nitrogen. And yeah, we've certainly seen in some sugarcane soils what's known as a PMN is a really important source of nitrogen for the crop. And it's not like a fertilizer nitrogen that's applied all up front and then dwindles away due to environmental losses. It's actually in the soil and is there for the whole cropping cycle. But I guess you also need to point out to some of the broadacre growers as well that you're on 2 metres of rainfall and you can actually grow that volume of biomass. So sorry, Brendan and others.
It's to us, we're having a light wet season this year. We probably only have around about 1,200 mils of rainfall, which is quite light for us. We're actually in a semi-drought sort of situation, believe it or not. Our soils just don't respond to light rainfall. We need the heavy rainfall We get a lot of runoff, but we also got to get a lot of filtration going in.
Just add water.
Yep, magic.
Fantastic. Any other questions for Richard from anyone?
I think that was just an interesting point from Lucas. And I think you were alluding to it, Richard, what you were saying, that nitrogen. It would be interesting to look at that nitrogen use efficiency of chemically applied nitrogen, as you call it, versus the organic nitrogen. We've found in some of the trial work we've been looking at it in end management in cereals, where the nitrogen use efficiency of urea, particularly in that first season, is nothing like we were told. You know, we were always working off that 50% rule, probably more 15%.
Well, just going on to the SRA soil health project that we're involved in, and that we have 3 demo sites throughout the district. We started those off a few years ago. Farmers did their standard stuff, and we did what we call an improved farming system. Controlled traffic, 1.8 metre rows, pre-mounted before the wet season, legumes planted into it, multi-species legumes, the same as this here. And we've done some assays, and SRA technicians that did a lot of the assays on it. We could reduce our nitrogen by around about 40 to 50 kilos in this particular trial. And we ended up with the same yield at the end. And that plus or minus 1 tonne a hectare. And that's so that there can be attributed to anything, just have a 1 tonne a hectare change when you're playing with 110, 120 tonne a hectare. And that it's nothing, you could never measure it. So yeah, we're getting improvements. We're actually getting a number of growers, like I said before, adopting some of the stuff that we're coming up with. And I've got to take my hat off to SRA. And that they've been really instrumental in pushing this whole program along. And yeah, we're getting adoption. We're slowly getting people to change their methodology. It's a long, hard slog, but we will get there eventually.
Fantastic. Thanks very much, Richard. That's really awesome, all that that you've shared. And if anyone's got any more comments or questions or whatever, just use the chat box and have a chat. So we'll just keep moving along, and we'll be interested to follow up on some of that microbial resilience work that the Soil CRC are conducting as well. So thanks for mentioning that, Lucas. So, Richard, if you want to stop sharing it, thanks very much. So we'll work our way down, and perhaps Sarah from Chirrup, are you happy to share something from what you guys have been up to?
Sure, sounds good. So I've been working in the Baliando, Sutter and the Cape and Campaspe subcatchments of the Burdekin, and we've been doing a project called Regenerative Grazing Tools for Burdekin Soils and Pastures. And I'll show you a quick map of the area that I'm working in. There we go, can you see that?
It's on its way.
So the area that I'm working in goes from, it's on its way.
Yeah, we've got it.
Has that come up yet?
Yeah.
Yeah. So we cover quite a large area. So we've got properties out as far west as north of Pentland, coming into around Charters Towers, into the Burdekin Dam, and then coming around. So that this area up in here is the Cape and Campaspe area. And then coming down here, we have the Sutter catchment, and the Baliando is this section down here. We've got groups of 8 and up to 8 in each producer group. So we're very excited to get more than targeted 5 growers involved. The main purpose of this project is to help build the landholders' capacity to build their understanding in their soils and how they can manage the health of their soil through their grazing management techniques. Taking into consideration that we're experiencing quite variable climate conditions at the moment. So just helping them build their knowledge and understanding on how to use different decision-making tools to improve their soils and pasture and in turn productivity. So what we've been doing at the moment over the past few months is collecting soil samples. And so we've been doing that in quite a big area. We've been looking at getting, can you see that slideshow?
Yes.
So what we've been looking at is we've been wanting to get a benchmark of the soil, where the soil is in each of the catchments. So we've been collecting 3 soil samples on each property, and we're in the process now of compiling the results and putting together a benchmark report. Yeah, we've quite a large range of, we've got clay soils all the way through to sandy soils that we've been working with. And for, we're looking at monitoring them over 4 years. So we've got the soil samples in year 1, and we're going to also collect forage budgeting data at year 1 as well. Record the forage budgeting data over 4 years and then retest the soils at the end of the 4 years. One of the main, what we've taken away so far from particularly from in both the Sata and Valley and Doe catchments. So I'll point out, this is in the Sata, these paddocks here, and these ones. And then we've got a couple in the Burdekin, so one in the Burdekin here and one up here. They're looking at they're quite low in phosphorus, and that's both available and in totals. In the Cape Campaspe, one of the major takeaways from those soil samples so far is that we're looking at, there's quite a fair bit of the potential for soil acidity. And I'm interested to, we've been working with David Hardwick, doing a series of soil health workshops with each producer group. And he's just had a really good way of teaching the basics of soil and plants and how they all interact. And the landholders have come away with with an increased understanding of what's actually going on both on top of the ground and under the ground. So that's been a really good starting point. From there, due to the current situations, we've moved to a series of online webinars, and we're going to go through those, the soil sample results with each producer group. So I'm pretty keen to see how they unfold over the next month. With the Sutter group is a year ahead. They were originally a trial group, and they've come away with being able to see how their current grazing management practices are impacting soil health. And so they're looking at moving from set stocking to rotational grazing, fencing up paddocks to land type so that they can better manage the grazing that's going on in those areas, to incorporate more rest and therefore hopefully improve soil health over the long term. And what we've picked up is that there's quite a difference in the total nutrients in each soil sample and the current available nutrients. And so just discussing with David and the landholders and looking at different ways that we can unlock the soil's potential. So that's, yeah, it's getting a bit exciting to see this project through over the 4 years and actually hopefully be able to measure go back to those soil sampling sites with 4 years of improved grazing management and see what improvements there may have been over the time. So that has been mainly what's been going on. I've been doing a little bit of work with Colin Seiss and doing some one-on-one property visits with landholders in the particularly the Sutter region, that they have both mixed farming operations. In the Baliando and the Cape Campaspe, they're mainly grazing, and so we've been looking at how we can implement cover crops, such as what a few other people have been talking about over the morning. So that's and integrating cattle into that as well. So like rainfall has definitely has impacted that over the trial, or we were calling it a producer demonstration site. So that has been rainfall wise, we're coming in under average, but more than what, so average is probably looking at 800 to 1,000 mil, depending on where you are. So for some areas, and the average over the past 6 years has we've been struggling to get to that in quite a few areas of the Sutter Baliando catchments in particular. So yeah, we're looking at continuing that relationship there and seeing how that works out in, I guess, a broad acre farming scale, mixed grazing enterprises. I'm also working on putting together a video that's looking at trying to capture and spread the message of all the good work that a lot of the graziers and mixed grazing farming operations are doing in the area, and trying to help, I guess, spread the word of what they're all the good work that they're doing. So I'm hoping to get that up and out shortly. That's been mostly what we've been working on up here, and interested to see how these online soil webinars go.
Yeah, great. Well, that sounds terrific, Sarah. Sounds like you've been really busy. So really, I guess what I've taken from that is you're working on a lot of maintaining ground cover to try and protect the soil and cycle the nutrients and manage that sort of thing happening. Yeah. Yeah, great.
Yeah, that has been one of the key takeaways so far, is ground cover and plant diversity. And it's been really great to hear through talking to the landholders that we're working with that they're the key messages that they're taking out from the work we've been doing with them so far. So it's great. I guess I like to see the change that the landholders going through as well. And looking at also the social side of change. So yeah, it's been really, really good to tie that in with the soil work that we've been doing.
Yeah, so you're finding they're supporting each other and sort of encouraging each other to continue along the management that they're doing. Yep.
Yeah, yeah. And just, yeah, how open people are to sharing that have already made those changes and are implementing or have been rotational grazing for quite some time. So yeah, being able to build on those connections and share their knowledge as well.
Fantastic. Well, that's great. I think Anne's made some comments for you in the chat as well, but if anyone else has got any questions for Sarah or comments they'd like to make. Oh, we can't hear you, Cole. No. Still can't hear you. Not sure what else to do. Try now. No. Maybe try unplugging your ear things and plug them back in again.
How's that?
Yeah, beautiful.
Ah, it's all so easy. Sarah, I was wondering if you're using a grazing course to underpin some of the decision making.
So that's where we're heading. This first year's been looking at soils and building that foundation in the soil knowledge. And then this second year, we'll be moving on to looking at how you can make that connection between grazing management, what management techniques are supportive of increasing soil health. And forage budgeting is quite a big component of this project. So that's where we're looking at taking this in years 2, 3 and 4.
Yeah, cool. Sounds like a great project.
Thanks.
Right. Thanks. Thanks, Cole. All right, well, we might move on, but yeah, like I say, use the chat if you want to ask some more questions or follow up with Sarah at another date. So thanks very much, Sarah. It's great to hear what you're up to and the successes that you're already having along the way. Kel, would you like to go next as we move our way down the coast?
Yep. Again, I'll see how I go with this sharing screen thing.
Yeah.
So that should be.
Yes, that's good.
Yeah, full screen for everyone.
Yeah, we've just got it. Just pop it into slideshow mode, perhaps. Or you can just do it like that. That's fine too.
Sorry, not sure how to get that full screen. Okay, so this is the project that I picked up January last year. It's a bit of a mouthful, the title, but basically it's EPA funded to look at ways to expand the market for recycled organic materials that come out of green waste bins in New South Wales, which are turned into compost. So the funding was provided to North Coast LLS to focus on trialling some of those products or demonstrating some of those products in the beef industry. So basically just applying them to the surface of pastures, grazing pastures, and just to see what would happen over sort of an 18-month to 2-year project. That was where it originally started. As with some of the other people today, the climate has not been favourable, and we went through most of last year for the coast, well below average rainfall, and actually didn't manage to get the project started when we wanted to. That is, apply our materials in sort of that February, March period of 2019. and then we missed another opportunity. Obviously, spring last year was still dry, and I'll talk a little bit about why we missed out again February, March of this year. So the project background is the North Coast region is a subtropical climate with a diversity of soil types. And the beef industry is our largest major land use. There's approximately 900,000 hectares of land on the North Coast, in the North Coast LLS region, that is defined grazing. And in an average year, based on our annual livestock returns, there's over 400,000 head that are over 6 months old. And the total cattle numbers of all cattle types are usually around the 800,000 number, with about 35,000, additionally 35,000 dairy cattle in the region. So it's a pretty big industry with a lot of land tied up in grazing. So our project design has got two components to it. One was to conduct a survey or an analysis of the industry itself, and to get their feedback and knowledge about compost as a soil health and pasture production option, as opposed to the more traditional fertiliser type systems. It's probably pertinent to note that on the North Coast, you talk to our beef officer, and it's normally described as a low to no input industry on the North Coast. The major driver is rainfall. And the photo behind you there is one of our sites, which I took the photo in January when I went back out after Christmas to see whether we could start to spread materials. And in January, everything was looking really good. And then we had anywhere from Christmas, depending on which site, from Christmas through to the end of March, there was somewhere between 400 and 800 mils of rain. And we went from being too dry to actually not being able to get onto most of the sites with the machinery that we needed. So we missed our window, our March window again. So we're in a bit of a negotiation phase with EPA at the moment, or Department of, in negotiation with EPA to see if we can extend the project into 2021 and into early 2022, so we can actually get a start on the project itself. That's another one of our sites in the background. Again, in January, we have 4 properties in the project with a variety of scale, soil types and pasture species. So we've tried to be a little bit diverse in the way people manage their grazing properties, so we can try and capture not so much the grazing practices, but the sort of philosophies that those people have in how they manage their stock and manage their land. And each property has a large 12-hectare site with replicated plots comprising of various composts and fertiliser rates. And I'll talk a little bit about those in a minute. And this is probably the important thing, is we've tried to make it as close to the real world as possible. So each of these sites will be integrated into the whole farm operation or grazing systems that those farmers actually use. So if cattle go into a particular area for 5 days and then come out again, we're asking them to record all of that data for us. So we'll be able to work out stocking rates and stocking densities later on. But we don't want them to try and treat those sites any different to how they would normally manage farm as a whole from a grazing perspective. So the market-based analysis of the industry, as I said, is tried to sort of delve into people's knowledge of composted products and what their benefits might be, and what they actually know about those materials as an amendment, and whether they know how they're made, whether they've used them in the past, and whether they understand any potential benefits of them, or why they don't use them or hadn't thought to use them in the past. And the second part, this is again one of our project areas, that's signal grass, if anyone was interested. I think it's one of the most southern paddocks of signal grass on the North Coast, and that's how it's kind of performing in January.
Kel, sorry for interrupting. I think we're still on the first slide for the screen that you're sharing. We're just looking at the first slide. Have you moved through the slides?
button. Maybe that's not working. Sorry guys, someone should have let me know.
Which slide are you up to?
I was about halfway through.
Okay.
So you've still got the title slide, yeah?
Yeah. So I'm not sure if you're moving the slides through on the screen that you're sharing, or if you're moving them through on a different screen, or if they're, because you've got like pictures in the background, it might just be happening really slowly because of the size of the pictures.
I might have hit the wrong screen. So what can we see there, guys?
Slide 2.
Yep, how about now?
Yep, that's good. Slide 3.
I might just do it this way then.
Okay.
So yeah, the market-based stuff, and
Yep.
then I spoke about fertiliser and the farms operating as a normal unit.
Yep.
The market-based industry stuff, which is talking about trying to understand why or why not people have used or not used compost products in the past, and try to understand get a bit of an understanding of their knowledge of those products. And then the field demonstration. So that's the signal graph. Everyone see the signal graph paddock? Just, yep, okay, cool. So what we tried to do is to remove the economic sort of bias from the sites. We designed our compost application rates to sort of best reflect what would be standard practice for the beef industry if they were to apply fertiliser materials, fertiliser products. So we've worked out 2 applications at 200 and 300 kilos per hectare. And then, say for example, 200 kilos of fertiliser cost $100. We would apply $100 worth of compost to the replicate compost site plot. So we can get a measure of what actually can go out for the same amount of money, and then see what the impacts are or the differences are by doing that, rather than saying to people, you have to put on certain amounts, and you know, the sort of the 5-10 tonnes per hectare. And when beef producers do the numbers, they go, well, that's just cost prohibitive to what my enterprise can sustain. So we thought, well, wonder what it would look like if we came at it from the other angle and took the cost out of it and just looked at applying materials at different rates. So we have 2 different plot designs. One has compost and fertiliser. So can you see my mouse? So FERT 300 is 300 kilos of fertiliser, and compost 300 is the equivalent amount of fertiliser based on the cost of 300 kilos of super, for example. A few controls, and then we've thrown in a 5 tonne per hectare of compost just to see. I suppose is the best, simplest way to describe it. We also have 2 farms that are organic. One is full organic, has been recently purchased. The other producer doesn't like to use artificial products. So we've just come up with a compost only demonstration for those 2 sites. So again, we're just looking there purely at different rates of compost from 1 through to 5 tonnes per hectare. And there is a little bit of a crossover. You know, 1 tonne per hectare of compost is roughly equivalent to about 200 kilos of super in cost, not in actual nutrient. So progress to date is the market analysis has been completed. There were 200 producers on the mid and far north coast involved in that. And I've got some of those results. We're still going. We got the report back from the people who did the analysis for us, but everything's kind of been parked for a little while we try and get the demonstration plots functioning as they're supposed to. And in the background there, you can see all the pegs all marked out. So this is a real world one here where there's sort of a 200 by 50, each plot's 200 metres by 50 metres wide. So there's roughly sort of 14 hectares within each demonstration. So the plots have all been set up. We've done all of our soil testing for the, each plot got a soil test. So that's 48 for routine ag and the soil biological properties. The tests were all done through EAL, Environmental Analysis Labs at Southern Cross Uni, and they sent away the soil samples to Melbourne to have them done for the soil biological property results that we got from those. So at this stage, yeah, it's been a little bit of a cursed project to be involved in the fact that we've gone from too dry to too wet in a few months. So we're hoping with a bit of negotiation with EPA, we can get an extension on the project and try and get 2 years worth of data and two applications of materials. So that's our plan, is to do soil testing at the beginning, soil testing at the end, and do seasonal pasture quality and quantity data collection as well. And then have the landholder, the growers themselves, producers actually capture all of their livestock data for us. How many animals were in a particular area for and what period of time. Collect rainfall data and that sort of information for us as well. So sorry about the glitches, guys, but that's roughly where that's at this point. Thank you.
Terrific. Thanks, Kel. That was no worries. Sorry, I should have picked up on that a bit earlier. I was sort of listening going, and then I thought, yeah, I was just waiting for a breath so I could pop in. But no, you did a great job. I was still following along, even though I wasn't looking at the pictures. So that's great. Thanks, Kel. That sounds like a really interesting project, and I'm interested to hear what people might have to say about it. And raised her hand. So, Anne, have you got a question?
Thanks, Felicity. Kel, that was really good. There's a couple of things I'd like to ask. One on, have you got the compost analysis for the compost? And secondly, how has the project managed contaminants as far as the compost is concerned, the green waste is concerned?
Yeah, yeah, two good questions. The first one is, the project is sourcing most of the compost material locally out of Grafton. So there's a company called Jindalee Ag who actually produce the compost materials. So each batch, for want of a better term, and comes with its own analysis. And as we haven't actually spread anything yet, we haven't had to ask for any materials to be delivered. Therefore, we haven't had to ask for any batch analysis, but that's the intention there. The contaminant thing, yeah, they have a fairly rigorous process that they go through to try and reduce that down to as little as possible. But the focus is it's only on the source separated organic materials that come out of green bins. Nothing that comes out of tips trying to separate the materials themselves, because that's actually not allowable in New South Wales at the moment. EPA put a sort of moratorium on that. So we have had to be quite clear on that it's purely the green waste materials delivered to the site, delivered to the plant and processed by Jindalee Ag. And they have a plant at Grafton, they have another one down at Albury, I think, and one out towards, it's gone out of my head now, Manildra, I think. It might be three, I can't remember now. But they do a lot of work in spreading materials in different other ag enterprises. They've done a lot of horticulture stuff with vineyards, starting to move into this more broad acre cropping and livestock systems, yeah.
Very good, thanks, Kel.
Thanks, Kel. And you would have heard from Nancy, who's the program leader for Program 3, and the Soil CRC doing a fair bit of work in this sort of organic waste stream and looking at new products for fertility and function.
Yeah, really interested to see that some of that stuff comes together as well. Yeah.
Yeah, and I guess I'm interested also in how you sort of separate the nutrient components and the soil health or soil function components of that demos that you're doing. But I guess it's about collecting the data and that sort of thing.
It's an interesting question. It's come up a couple of times from talking to different people, and I went to the Soil Organic Matter Conference in Adelaide last year and heard a presenter, and she talked about that, being able to pick apart what's causing things to happen and how you should set up either your research plots or your demonstration plots to try and delineate or pick that apart much more easily. So some things we got right and some things we're going to have to try and work our way around as we go.
Yeah, but it's difficult with organic amendments when, I mean, I guess Anne had that question about, what the analysis of the product is and how you compare that to a product that comes from a bag that's got to be made to a specific analysis as well. So
one of the big unknowns, Felicity and Kel, I guess, of the organic amendments, and a lot of industries are asking that now. When do the nutrients release? And that's in part due to the mineralisation of the organic matter in that compost or in that bag of organic amendment, and that depends on a whole stack of other factors like soil microbial activity, which is driven by rainfall mainly, and temperature. So there's a whole stack of complicating factors, and it'll be different every season, and probably from every batch as well.
Yeah.
Question, Kel. Well, why did you choose green waste as a source of compost? Is it just because it's obviously lots of it down?
Yeah, and it kind of drops back to the title of the project, which was expanding the market for source separated organic materials from green waste. So that's where the funding came from.
Yeah.
So effectively, that's where the material is sourced from. Yeah.
Yeah. Because I would naturally assume being green waste is going to be a lot lower in nutrient value than what obviously, chicken or feed or compost.
Yes, we would expect that. And when Nathan Jennings, who's been helping me put it together when we picked it up last year, and looked at the design that was originally proposed for the project when the funding was put up, he had a report, or a project was funded by GRDC, I think it was, where they compared sort of organic compost to the regular fertiliser regimes, and that was quite an interesting report in the way that project was done. So we took some of that away as well, and when you looked at the results, and you're right, the nutrient value of a fertiliser and an organic compost is completely different. But then to look at the results that they were getting in some of those pasture project areas and graphs, it was quite interesting that the difference between the responses wasn't as great as what you would anticipate, based on the nutrient value of the two products. So we kind of thought, well, there's something else going on in the soil that's not being measured in that project. Whether it's possible to unlock this with our project, probably not, but it sort of lends itself to what everyone else has been saying, that there's sort of interactions going on with these materials within the soil that are giving you different plant responses that maybe weren't anticipated from purely just comparing an inorganic fertiliser to an organic compost, for example.
Yeah. Oh, absolutely. I don't think there's any question that there's so much here that we don't know, and the thinking is it microbial, organic carbon, all these types of things which are really hard to analyse, to put a figure on. It's really easy to put a dollar figure on a nutrient value. That's why we do it. They're trying to understand organic carbon, microbiology and all these biological things. It's just, I don't know, it's expensive and no one understands it.
Yeah, and whether it's more of a case of saying, like with Sarah's project, if you implement these sorts of practices on these soil types and do it this way, is that enough of the understanding? Or people are always going to want to know why it happens. But like you said, it's very expensive and there's a lot of unknowns. So it's interesting.
Mm-hmm.
Thanks, Kel. That's awesome. All right. Well, we'll keep moving along. Yep, because some people have got to head off. So, George, are you happy to go next? Yep.
Yep.
I'm going to head off, guys.
No worries. Thanks, Jasmine.
All right,
See ya.
thanks, guys.
You can see that, everyone?
Not quite.
I know. It's all good. It's all right. All good. Share screen. Yeah. This one.
Yep.
Very good. Very good. Rightio. So I was just going to do a quick update on what we're doing in Northwest New South Wales. I manage the Resilient Regional Agricultural Project, which is funded through NLP2. And I guess it's really about motivating landholder change. So unlike some of the presentations today, very specific projects, this I work very broad level, looking at a number of projects and all about, yeah, motivating change. So this is funded through the NLP2, which I know many of you will be familiar with, but all about adjusting to climate variability and so forth. But one of the additional benefits from this project is to improve and protect the condition of soil. So I've just pulled out a couple of our soils related projects that I just sort of wanted to run you through on. I guess what I'm keen to hear back from, and I know Sarah's done some work which is great, is ideas for extension. So because we're all about trying to get people to adopt changes. It's great receiving funding, but we're trying to encourage people to make these landscape or on-farm changes without having to rely on external funding all the time. So it's really about trying to sell the adoption of this change. So the projects we've got quite broad across the Northwest. These are just the NLP2 ones, and you know, range from the north up where Anne is near Moree down towards Blackville, which is down towards the Hunter Valley. So just a couple of the projects. One of the ones is the Wallabadar Creek catchment near Tamworth. Some of the work that they're really doing is trying to, you know, benchmark this soil carbon, and I guess this comes up in all the presentations, and it's really about trying to ascertain where they're at, so they can sort of try and identify, you know, are they making any changes? And as you'll see with quite a few of our projects, they're also a big emphasis on trying to rehydrate the landscape, and it really has come through as one of the major projects for a lot of these groups this year and over the next 3 years is trying to you know, get water into the soil, make it more usable, and help to, you know, increase productivity. So I guess some of the extension activities here we're looking at is you know, the field days and the videos, and but particularly here is trying to link all this data. So trying to draw some correlations on how things are connected to really drive the change. West of the area, west of Narrabri, Merrimburra, Yarra Lake, Landcare Group area, big emphasis on water spreading and water ponding. So you know, really flat, sodic, really hostile soils. A bit like some of the stuff that Tim showed on one of those water infiltration meters, and I think it'd be good to try and borrow that rainfall stimulator and bring it up to this site, and maybe put it in some of the areas where we have done some ponding and in some of the areas that are untreated. So yeah, just all about trying to you know, help these soils to become a little bit more productive. So slowing the water and better utilisation of it. Baba Gullion is just near Tamworth, and here you can see another form of banks work that's gone in. It's a water spreading bank, quite different to some of the ones we've seen out west. They're slopier country, but yeah, with an emphasis on trying to get some infiltration and slowing the water as it moves down the slope. This project here is combined with some cover cropping. They're going to sow across the banks once they stabilise a little bit with some multi-species. So we'll actually be looking at monitoring that, the germination, and looking at biomass and a few other things there. And this is also being established as a demonstration farm because it's only about 100 acres. It's quite unique to the Tamworth area in that there's a lot of these peri-urban blocks. And I guess we're trying to, they actually cover large areas of landscape. So we're trying to encourage on some of these smaller holdings, some techniques that can be utilised to, that are cost effective, that can increase these, the productivity and also the sustainability of these, some of these smaller holdings. And then we've got the APSIM grower group. So looking at plant available water. So quite a bit of work going on there, trying to, this is more in the cropping areas, trying to give better thresholds to managing soils and knowing when to plant a crop and when not to, because of the limited water resource that we're finding. And then up around Bingara, we've got some hydromulch work happening. So a soil demonstration farm. So as you can see from the picture, it's about spreading seed impregnated with all sorts of nutrients, spraying it onto the landscape to try and increase that cover and get some germination. And then the Northern Slopes Land Care also doing some work looking at soil characterisation, ground cover, plant diversity, all of the things that we've been talking about. So there's just been a really big emphasis on people looking at their soils. I guess, you know, we recognise it's the basis of everything, and they need to really to adopt change or to drive change. They recognise that importance of starting at the with the soils as a basis. And then there's a lot of, we've got quite a bit of natural sequence farming happening, and this is in conjunction with Anne Coote. So lots of these delves of these small drains, small banks around the landscape, trying to slow the water because, you know, with the climate that we're getting, unlike this year, but the traditional dryness, it's all about trying to capture water and better utilise it. So great work happening. But I guess there's a lot of work happening out there, and I guess my challenge, or our challenge that we're finding, is getting the extension. So, you know, developing up the tools, trying to sell, you know, these concepts, and that's the paired project that Anne and I are looking at, is how we develop up some tools to better promote the application and adoption of some of this work. And as Anne said, you know, we need to slow the water, and here's Stuart just demonstrating with a garden hose how a little bit of a bank on this little bit of a flat scalded area can slow and divert the water. So it's looking at some of these basic techniques to try and to get the messages out. And we've got a little bit of obviously some pasture cropping happening as well, which is all then linked in with the soils. And as Anne introduced herself, we've got Anne Coote and Lana Andrews are the Ralphs in our region, so it's very collaborative work. They've also got some work happening with dung beetles, which is great, and I see it's on the second page of the Land today, a big thing about dung beetles. So yeah, it's great to obviously that's linking into the soil and soil health. And I think I'll let that some catchment management. So yeah, sorry, it's only a brief overview, but in the interest of time, it was just a quick overview of what's happening in the north. And yeah, the fact that soils are have really shine out as one of the key things that people are looking at. I think that's great. Then with the soil CRC happening, that was some great opportunities to work out some extension and to adopt these techniques.
That's great, George. Yep, fantastic. And yeah, great pictures illustrating.
Yeah, I was just going to say that last slide is, yeah, some of the water spreading there, water ponding out at Wobbegard just from the drone. And that's a site we've had going for a couple of years. And it's, yeah, we're really starting to see the benefits. It's about actually measuring them and then trying to put them into economic value, I guess, is the big thing. I'll stop the share there.
Yeah, fantastic. And yeah, I'm really quite conscious of that that part of us getting, increasing our skills and knowledge, but then also having the tools to be able to impart that onto landholders and to support landholders to make that change. And Soil CRC are doing quite a bit of work in that space. So I've been talking with Vaughan Higgins, who's a project leader from Tas Uni, who's doing some work on why soil management practices are adopted. So we might get him to have a chat to us about the work that they're doing and any tips and tricks that they might have. And yeah, so program 1 and has got a fair bit about that sort of, you know, extension tools and risk assessments of new practices and building farmer innovation capability and those sort of projects that are going on. So yeah, any questions for George? Comments? No, that's all good.
Glad you all stunned.
Yeah, no, it's good. You've given us a great overview, and I guess yeah, something to go back and to share, and for others to have a think about what you're doing and how they could help you to think about how you're doing some of your things a bit differently too. So yeah, Cole said he's doing some work. So. In the chat, so perhaps have a look at that, and yeah, and also have a look at the Extension Oz site. Did you join up to that Extension Oz site?
Yeah, no, I have, Felicity. Yep, for sure.
Great, excellent. All right, terrific, George. Thanks very much for that. And yeah, Cole is lucky last, so thanks for hanging on, Cole. And yeah, if you've got something to add in your presentation to something that George has done, feel free to mention it. But thanks, and yeah, happy for you to share something with us.
Hopefully I'll be able to do that if I can find my my document, which I can't. Let's try that one. Can anyone see that?
You have to do the share screen thing down the bottom first. So along the bottom of the meeting, there's in the middle of the box, there's a green box that says share screen. So if you click on that and then choose the screen that you'd like to share. I think we've lost Cole. I think he's dropped. Oh, he's closed his browser. So he's left the meeting. Unfortunately. See if he comes back in. I might just see if I can give him a call. He might not have realised he's dropped out.
Sorry about that. My computer died at exactly the right or the wrong moment. I'll try and get this share thing happening. Can anyone see that?
No, not yet.
I've hit the little green doover at the bottom.
Yep, so then you've got to select the screen that you want to share. So when you hit on that green button, all your screens should come up and then you can choose the screen that you want to share.
Yeah, I thought I did that, but I obviously failed.
It's a bit of a trick.
Yeah. All right. No, the thing I want to show isn't coming up.
Oh, okay.
All right, look, I'll close it and try one more time.
Okay.
This one.
Yep.
All right, the gist of what we're doing, you can see something there now?
Yes.
No?
Yes, we can see it, Cole.
All right, I'll just keep talking. We were recently successful in attracting some smart farm presentation I had, but I'll just speak to it. We were recently arms program to run a trial of the soil key implement. I don't know whether anyone's familiar with it, but last year the fellow who developed it, Neil's also carbon credits for soil carbon, and he was able to increase his carbon with the use of this implement. Basically, it's a seeder. It has a rotary hoe attachment as part of it, and the rotary hoe inverts about 20% of the grass on the pasture on the soil surface, and he uses it to plant a multi-species annual mix for the winter feed gap. Some of the early results that came out of it show that he was getting increases in biomass production and crude protein, but also improvements in nutrient availability. Phosphorus, I think from memory, became 34% more available after using the machine. He claims to be producing 2 or 3 times the biomass production on his paddocks that the local average would suggest is possible. He's doing that with no fertiliser amendments, he claims. So we're trialling it here. We're cooperating with a local land and beef group who are putting up 2 sites. The dairy development group, where a dairy farmer is putting up 1 site, and Tocal College, who are putting up a site. So we'll have 4 demo or trial sites. We're not really a research organisation. 2 of those will be on alluvial flats where we'll be looking to sow that multi-species annual mix for the winter feed gap. But in the other 2 sites, we're looking at going on to some of our slopey country, commonly relatively poor duplex soils, also fairly commonly carpeted with carpet grass and couch and fireweed, not fabulously productive paddocks, to look at whether we can use this implement and the method to establish or renovate those pastures. We're also doing some carbon testing using the CFI methodology. It's only a 2-year project, so we probably won't come up with fabulously useful results. But as with the rest of the trial or the demonstration, it's really a rush of blood. There's a new thing, so let's have a look at it, and trying to prompt a bit more interest in the general area so that someone may take it on and perhaps do larger trial plots or different trials to what we're doing. We've also got a landholder, one of the Dungog Gresford Land and Beef Group people who's providing a trial site, who's interested in another research question, and that is, do you need to buy a $90,000 machine and use it to sow your multi-species seed mix, or can you just use a super spreader or something low tech that you've already got and do that? And the research question being, if there are benefits in the results, do they come from the machine or do they in fact come from the multi-species mix and the biology that's associated with that? Worldwide, as you'd be aware, there is a bit of a story that a multi-species mix can, through cooperation of the various species and their root systems and their associated biology, produce some fairly amazing results all by themselves. So that'll be an interesting question. I think that's about it for me.
Okay, thanks, Cole. Has anybody else seen the soil key? Yeah, no? It was used down in, sort of southern Victoria. Gippsland is where the guy came from. Sorry, Cole, you might have said that already. So, yeah, it's an interesting concept. They were actually able to get the first soil carbon credit in a broader or in a sort of farming situation, I think.
Yes.
Yeah.
The fellow who developed it estimates that the soil carbon credits are worth around $150 a hectare potentially.
Yeah, okay. Great. Anne's got a comment, question?
Cole, just in respect to the types of equipment people are using, they're using for planting multi-species, constitutes machines, oil scarifiers that people have actually putting planting boxes on, small seed boxes, right through to the very expensive units that I've seen people purchase for contracting over in the tablelands, which are really smick machines. The important thing is when you are mixing them, because you've got a lot of small seeds generally in with that mix, that you're actually getting them where, in the right placement in the soil. But I genuinely think that it's like anything, if you put them in the right place to give them the best advantage, then the other thing, the soil components, the plant diversity and the microbial activity is probably going to be obviously of greater benefit. So we can't shortcut getting the little seedlings where we need them to be, like any crop.
Yeah, good point. And one of the plots is just the double wheel seeder that a lot of the locals use to see if to ask that question exactly. Is it this particular bunking new machine that's important, or is it something else? And just a super spreader, basically broadcasting it and putting some stock in after it, whether something really low tech like that can work as well.
Absolutely, and I think that's got its place depending on the soil type. And the other thing to consider is tines versus discs, depending on your soil type. Same with any other cropping, it's horses for courses, and what people are prepared to play around with. But yeah, I think that we can utilise a lot of the things that we actually have or that are sitting underneath the tree, rather than spending a massive amount of money on big equipment.
Yeah, and it goes to that extension and adoption thing that George was talking about. If you've got to sell the idea that you need a $90,000 machine, maybe the practice or the innovation isn't as adoptable as if you can do it with something you've already got.
Absolutely. So can you actually give us a bit of an update on the research that you've done with extension theory and adoption?
I can, if people are interested.
We've got time, I suppose. Yeah.
Yeah, well, we've done quite a bit of work at Hunter LLS in the last 18 months. Our board asked us to demonstrate to them that what we were doing was going to hit all the outcomes in our strategic plan. And so that's really what I call a program theory approach. Some of you may remember or be aware of Bennett's hierarchy and have used that. Generally in program and project planning, we only do one side of Bennett's hierarchy, which is about the process that the steps, seven steps that people go through between awareness and ultimately adoption. There's another side to that, a left-hand side, where you begin with the outcome in mind, and then you look at the root causes for why outcomes are currently suboptimal. And the idea is that that directs where you go and what you do and who you do it with. So we've done that and in the ag team, and we've identified the suboptimal outcomes, and we've identified why we think it is that they exist. We've then done a client segmentation and found that we have 4 different types of clients amongst our beef producers. And then we've done a producer segmentation. So we've used some typology stuff that actually came from the MLA, which has 5 types of people. Those types of people are all have different barriers and attractors, and they're all interested in different things. So it gives us some idea, and fortunately they worked out to be about 20% for each of the 5 categories. So it's nice, even arithmetic. Gives us some idea of what percentage of the population are likely to actually be interested in adopting what we're promoting, whatever particular innovation or practice change that is. And then we have an extension model, which is based on Everett Rogers' diffusion of innovations model, which is from the 1960s, but with the fairly recent addition of a chasm in there. And if you can imagine that the Everett Rogers adoption model is the normal curve of adoption, it's the one with the laggards right over on the right-hand side that you may all have seen. The idea with the chasm is that as you go from the left-hand side of this normal curve, and you've got people I call the thunder lizards, who are right out there at the cutting edge, and after them, the early adopters, and you do start to get a percentage of the population trialling or adopting something, but then it stops, and that's the chasm, and something has to change there. Either the innovation needs to change and be made more adoptable, or there needs to be some change in the approach and the awareness to the broader population. And the group of people on the right-hand side of the chasm, who in the model account for about 34% of the population, are termed pragmatists. And their story is not that they want to be out the front being heroes and researchers and entrepreneurs in that sense themselves, but their story is, show me someone like me doing this and getting a benefit. So our extension model, and that then becomes the first plank in what we call social contagion, where the idea might move more broadly through the community and be adopted by people that we call conservatives in that typology. So our extension model is to look for those pragmatists who want to see it demonstrated and use what we do, a bit like the producer demonstration sites that people were talking about before, with the purpose of demonstrating to the locals that people like them in their circumstances can get a benefit. So our incentive funding, not that we have very much, but within the ag program, our extension funding goes to that point, trying to set up those demonstrations. And we're looking in particular recently at the concept of relative advantage. We've used it in the past. One of the things we do in our program planning is we use the CSIRO's Adopt tool. I don't know whether anyone's heard of it or used it, but for any innovation, you can answer 20 22 questions about the population and the innovation, and it will predict the time, the level of peak adoption and the time to get there. They claim around 87% accuracy on that, based on their experience predicting the adoption of other things. We find that useful because it's a good discipline to have to come up with the answers to all of those 22 questions, but it also gives us a testable hypothesis. If we do what we do because we think it will work, we expect to get this sort of uptake, this sort of level of adoption. If we don't, then that's a trigger to go back to those 22 questions and look at which bits we got wrong. And it could be about the innovation, or it could be about the people, or it could be about the way we're presenting it, which would be the extension thing. But currently we're looking at relative advantage in particular. The default when people talk about relative advantage has always been, does it make $1? And that's obviously important. But the literature would suggest that farmers have financial, environmental and social values that need to be reconciled if they're going to make a decision. So we're looking at our NRM practices at the moment to see whether, in fact, they have any relative advantage, and the likely fact that they don't could explain why there's a relatively low level of uptake. Sorry if I got into a rave there.
That's it's excellent, Cole. It's interesting, on a paper that I've just recently read, and I will share it with you. It's about a study, it's a research paper on the adoption of regenerative practices in Australia. So it was actually done down the east coast of Australia. There was about 24 producers interviewed. It's quite an extensive document, but there's some really key messages in it. The reason people adopting new practices are because we all know the value of farmer groups and the connectivity that we can get with a farmer group. So in addition to the farmer groups, if I back up a little bit, it's about changing a paradigm. It's about changing a mindset to actually what you want. And when you explore that, you find that there's spiritual and political barriers as well within communities for change. And this paper explores those things quite well, and it gives you a really good understanding as to the components of the thinking that you actually go through to, you know, for people to change. The other interesting fact with all these people were that they had previously done training, and someone mentioned training before. I think it was Brendan asked what sort of training had some of these people done with regard to either Sarah or I think it was Sarah's project. All these people had done a holistic management course or an RCS course of some description. So they stood apart by actually analysing their whole business, including themselves in that, and not just a specific adoption of one particular part of their business. So the other work we've been doing is on complexity thinking, where we're dealing in a complex environment which can't function singularly. So we have to think about things differently and approach them differently to the way we've thought in the past, in a linear fashion. We you know, if we want change, we've got to think about complexity, and we've got to be able to think about how it is we actually are going to get people to actually, what's going to trigger them to think about where they sit and what's of value to them for the longer term. Why do they want to be there? And what are they going to do to make sure that they're there for the next generations? And soil's critical to that process, but there's a whole range of other things that come into play. So it is a challenging space, but it's really interesting, the work that's come out on complexity thinking. I'm happy to share those documents with you.
All right.
Thanks, Anne. Yeah, I mean, we could have a chat all day. This is a whole other topic for discussion. So I'm just conscious of time, that we've been sitting here for a while. So thanks very much, Cole, for the bit about the soil key. I'm really interested that you've had the opportunity to have a go at it. And I really look forward to seeing some of the results that you might find coming out of that.
Felicity, we haven't had a go at it yet. I'm having the devil's own time trying to line up all the ducks.
Okay, right, yeah, because I imagine it's fairly popular. I've seen sort of bits and pieces of it popping up across Victoria. So good luck with that anyway. So yeah, be interested to see how it goes. And I'm keen to continue to explore that topic on adoption and change and practice change, because it's relevant to all of us in the work that we're doing. So I'll certainly bring that into the communities of practice to support the work that we're doing. So thank you very much, and I encourage you all to catch up with each other if you have further questions from each other in regards to the projects that you're doing. Lucas, did you want to say something?
No, I just wanted to thank you, Felicity, and everyone else for your presentations today. It was really interesting, and I learnt a lot. So thanks, everyone.
Excellent. No worries. Well, thank you, Lucas, for joining us and for supporting and prompting on each of the where the soil CRC projects fit in with each of the works that each of the communities of practice are participating in. So that was really valuable. I appreciate that. And yeah, I'm glad that you've got something out of it as well. So that's been great. So probably from at this point, thank you all, yes, for participating and your discussion and questions. It's been fantastic. I'll be in touch with each of you regards to the paired activity. I have received feedback from some of you, so that's been great, but I think I've heard from Brendan regarding a topic, but Tim, I'm not sure what your plans are, so perhaps if you want to get in contact with Tim, so Tim and Brendan could perhaps pair up, and Jasmine and Richard, if you've got something that's relevant to both of your works. Thanks, Richard. And yeah, if you've got any queries about how you want to run it or what you think you need to do, I want it to be something that's certainly soil management related, could be soil CRC related, or something else that you're currently doing that would be of value to share with the community of practice that is related to the topics that we've identified in the capacity building plan. So, and it's just about, yeah, sharing some information and working together to do that. I'm going to be working on developing up the Extension Oz platform so that we could use that as a vehicle to share information and store information, and also get some support from the soil CRC researchers to put some information up on that site too. So I might tap a few of you on the shoulder to perhaps be involved in that process, or just get some ideas about what that might look like for you guys. And going on from here, I'll probably look at organising some webinars for you guys to participate in, so that we can keep connecting and keep learning and sharing information. So I've been talking with Lucas and the other program leaders from the Soil CRC to identify some good presenters that we could have on, that we could join up together, and they can share their information and expertise, and you can pick their brains as to how you can use that information in the work that you're doing, and to build your knowledge and skills to help your groups and landholders that you're working with, and to support the research that you're currently doing and any research that you might be doing in the future. So that's where we'll sit. If anyone's got anything they'd like to say now, please fire away. Any questions, comments? No, everyone's happy? Great. Fantastic. All right. Well, you know that I'm always here, and if you want to send me an email or give me a phone call, I'll probably follow up with each of you just to have a quick chat. But you'll be hearing from me in the not too distant future about rolling out some future webinars or web meetings, and we'll hold them like this so that we can have some discussions and share information, and we'll go from there. And I wish you all the best. Stay safe, keep washing your hands, and hopefully we'll all see each other soon. So thank you. Thanks everyone. Thanks
Thanks,
Lucas.
Felicity.
No worries.